Wish him to you. Happy birthday to you. Happy birthday to you, sir. Happy birthday to you.
Vinayak, singing happy birthday. Ramya,
Output change ಮಾಡಿ. Output.
thank you very much. Listen. Thank you very much. Hope you enjoyed the program. We have started it after 3 years, and we are delighted that you're all here. Vinayak, you sang very well.
Thank you, madam. Thank you very much.
Fine. Ganesh.
Test. Good morning, everyone. Sound aston clear illa. Okay. Good morning once again. Good morning, sir. Very nice. Okay. And welcome to the award function for the outstanding science teachers. We begin the program to award the outstanding science teachers for the year 2020 and 2021, donated by Bharat Ratna Professor CNR Education Foundation, and followed by the lecture program. Around more than 25 schools and colleges participating in online platform, and they are in online, even you are in offline, it is in hybrid mode. Yeah. Now, I request Mr. A. N. Jayachandra to welcome the gathering and continue the session. Thank you. Over to you, sir.
Good morning to everyone. Respected Professor CNR Rao, Professor G. Kulkarni, President of JNCASR, Professor MRS Rao and Professor V. Nagaraja, past Presidents of JNCASR, Professor K.S. Narayan, Madam Indumati Rao, the Trustees of the CNR Rao Education Foundation, importantly, the teacher awardees, the jury members of the selection committee, faculty members of JNCASR, officers, and staff members of the center. It's a great pleasure to welcome you all to this event on behalf of the JNCASR as well as the CNR Rao Education Foundation. To begin with, may I congratulate the three science teachers, Sri Bhimappa from Raichur district, Karnataka, Dr. Ravi Prakash from Bareilly, Uttar Pradesh, Sri Vidyadhar Yadagiri from Vijaypura district, Karnataka. Thank you for being with us, and they are the recipients of the awards of 2020 and 2021. And I welcome all the three awardees and their family members for this program. On behalf of all of you, it's a great privilege for me to wish Bharat Ratna Professor CNR Rao a very happy birthday. Though he is online, the gracious presence of Professor CNR Rao, Mrs. Indumati Rao and Sanjay Rao has brought a great deal of happiness to all of us, and as well as those who are viewing the program from throughout the country, from various places, and I extend a warm welcome to all of them. Friends, on a personal note, you are all aware that the birthday is a special event for everyone in their life. People celebrate birthdays in many ways. We have heard of birthdays being celebrated in star hotels, important destinations, in the air, under the water, temples, and many places. And Professor CNR Rao, given his stature, can enjoy his birthday in every which place. However, here is an example of this eminent scientist celebrating birthday by honoring science teachers in the presence of many future generation students. It is not just that. The CNR Rao Education Trust is also treating us with a feast of music in the evening by an eminent artist. Personally, I feel that this indicates the values Professor Rao desires to teach the next generation to come. And for this great gesture, I thank Professor Rao and family and the CNR Rao Education trustees for this great gesture. Just for the benefit of the school children and teachers who have gathered here, I would like to introduce JNCASR, the Jawaharlal Nehru Centre for Advanced Scientific Research, as a multidisciplinary premier research institute under the Department of Science and Technology, Government of India, founded by Professor CNR Rao. Professor CNR Rao was the first president of the center. Pursuing fundamental research in the areas of materials, nanotechnology, molecular biology, evolutionary biology, theoretical sciences, engineering mechanics, and other areas, this institute awards PhD degrees, MSc, and other related degrees to the young students, young and bright students from all over the country. With the breakthrough research and a large number of high-impact research papers, the center has drawn the attention of the world and has been rated as one of the best places for research internationally. So, to you all, you can also make to the center as students some point in time and choose this as your destination. While this research institute is seriously engaged in frontier areas of research in science, through the visionary idea of Professor CNR Rao, we have been the pioneers in connecting young minds from all over the country to bring awareness through our outreach programs. In this regard, decades back, JNCASR initiated various programs for the college students to know about science. Coming back to today's program, the CNR Rao Education Foundation is a family trust of Professor CNR Rao and family, and this was registered in the year 2005. The objectives of this trust was to promote science and technology education, particularly among the deserving students of the country. The foundation contributes to science education and outreach programs in various ways. They are recognizing dedicated science teachers at the school and pre-university levels, one in the state and other outside the state annually. Every year we choose one teacher from Karnataka and one teacher from rest of the country. And the foundation is also involved in creating scholarship for deserving students in some colleges as also in premier institutions like Indian Institute of Technology, particularly in Kanpur. The foundation internationally has its existence and has entrusted the Academy of Science for Developing World, it is called TWAS, with its headquarters in Trieste, Italy, with the task of identifying deserving and talented scientists in the least developed countries to award prize at its general conference. In remote places of the country, including one in the Himalayan range of mountains and one village in Karnataka, the foundation has established lecture halls and annually various outreach programs are being conducted in these places. In addition to that, a national prize is instituted by the foundation to recognize talented researchers in the area of chemistry, and every year in different areas of chemistry, the national prize is awarded for the best of the researchers, and this involves a big prize money and a citation. In addition to all these things, Professor Rao and family have been supporting various innovative and unique ventures in art, music, and other creative endeavors. So it's my great pleasure to welcome the students and teachers of various colleges from Bangalore and from various places who are assembled through online participation. In fact, it is your day. We have with us a great teacher and a prominent educationist, Professor S M Shivaprasad, Director of Karnataka Higher Education Academy, who will be giving a beautiful talk titled The Beauty of Science and the Science of Beauty today. While we look forward to listen to you, sir, a warm welcome to you. JNCASR is always endowed with resource persons from various areas of expertise. Our jury members of this award, who have been guiding us in the selection process with great pleasure. Okay, I welcome Dr. P.G. Dwarkanath, Dr. Srikanteshwara Swami, and Professor Ramaswamy, as also Dr. Gururaj Karjagi, who are all available online. With the philanthropic and moral support from the CNR Rao Education Foundation and help from the jury members, so far, more than 30 teachers all across the country have been given the Best Science Teachers Prize since the year 2005. Our past presidents, Professor V. Krishnan, who is online, Professor V. Nagaraja, and Professor M.R.S. Rao, who are with us, and all faculty members and officers and staff members, and particularly Mr. Jaideep Deb, the administrative officer of this center, is with us, and I welcome all of them. Very importantly, I welcome our president, Professor G. Kulkarni, Professor T. Govindaraju, the chair of the ETU, all the deans, faculty members, JNC students community, SMP mentors, and all present here, as well as who are participating online. Thank you and have a good day. In fact, we are all waiting for the award program, and I request the chair of the ETU, Professor T. Govindaraju, to read the citation and conduct the proceeding.
Thank you, Mr. Jayachandra. Good morning to all. In fact, on this special day and special event, which is very close to Professor CNR Rao, Bharat Ratna, Dr. Mrs. Sindhumati Rao, which is honoring the teachers, and in the august presence of students and guests. So it is indeed a great privilege and honor for me to read the citations. The Outstanding Science Teachers Award for the year 2020, one of the two awardees is Shri Bhimappa. Shri Bhimappa is a science teacher at the Government Girls High School, Maski, Raichur district for 2 decades. He has motivated and guided students to work on various science projects and won various prizes at state and national levels. Shri Bhimappa has received state-level Gnana Sindhu Award for excellence in the science field. Shri Bhimappa has conducted many science outreach activities for students and teachers. He has developed an Android app that could also be used offline for the benefit of students in rural areas. And he created several multimedia materials and distributed them to rural students. He has created a blog for teachers' resources and worked as a master trainer in science training programs. Shri Bhimappa made several contributions towards school development, bringing back dropout students to the school. In addition, he has conducted many science webinars for teachers and delivered many scientific lectures. The CNR Rao Education Foundation takes great pleasure in honoring Shri Bhimappa for his dedicated work for the cause of science. Now, I request Shri Bhimappa to come on the dais. I request our President, Professor G. Kulkarni, to do the honors. Sir. Shri Bhimappa has received this award in the category of within Karnataka. And now the other award, which is awarded to the teacher, outstanding science teacher outside Karnataka. So Dr. Prakash Sharma is a lecturer in Vishnu Inter-College, Bareilly, Uttar Pradesh, for more than 3 decades. He has made notable contributions to science and technology. Dr. Sharma is the recipient of many awards and recognitions. Notable among them are the National Teacher Award in the year 2016 by MHRD Government of India, the National NASO Science Teacher Award in 2013 by the National Academy of Sciences India, Lokamani Lal Excellence in Education Award again in 2013 by MPVM Prayagraj, Shikshak Shri Award in 2013 by Bareilly Scholar Society, Prayagraj State Science Teacher Award in 2008 by the Department of Science and Technology, Government of Uttar Pradesh. Dr. Sharma, as coordinator of District Science Club Bareilly, has communicated science awareness to teachers in science workshop and seminars, ED training and skill development program for self-employment to science-educated youths, and science popularization for students and citizens. He has published an article in the magazine NCSC Uttar Pradesh and in several newspapers, and also delivered science talks at Akshawani Bareilly. The CNR Rao Education Foundation takes great pleasure in honoring Dr. Ravi Prakash Sharma for his dedicated work for the cause of education. Sir. Moving on to the Outstanding Science Teacher Award for the year 2021. Sri Vidyadhar N. Yathagiri is a science teacher at the Government High School, Pirapur, Taluk, Muddebihal district, Vijaypur, for over 2 decades. He has motivated and guided students to work on various science projects and won prizes at state and national levels. Sri Vidyadhar is a recipient of many recognitions. Notable among them are state-level Gnana Award by Akhila Karnataka Jaina Shikshara Vedike in 2018, Sri Shankaralinga Tapasvi Award in 2017, and the District Best Teacher Award in 2015. Sri Vidyadhar has participated in many science exhibitions and seminars. He is a science resource person for workshops and teachers training programs at the district and state levels. He wrote many scientific articles and published them in newspapers and magazines. The CNR Rao Education Foundation takes great pleasure in honoring Sri Vidyadhar N. Yathagiri for his dedicated work for the cause of education for the year 2021. May I now request Sri Vidyadhar on the stage.
ಟೆನ್ಷನ್ ಕೊಡಬೇಡಿ, ಬನ್ನಿ ಅಂತ ಹೇಳಿ.
ಇಲ್ಲ, ನಾನು ಯಾವ್ದು ಅವಾರ್ಡ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಇದ್ದೆ, ಅದಕ್ಕೆ ಓಕೆ, ಪರವಾಗಿಲ್ಲ. ಇವತ್ತು CNR ರಾವ್ ಅವರ ಬರ್ತ್ಡೇ. CNR ರಾವ್
Here's a map of Karnataka.
Now it is time to hear our awardees. May I now request Shri Bhimappa to give his response.
Good morning, everybody. Honorable President and Chief Guest of this function, first of all, I wish a very happy birthday to our legendary scientist, Bharat Ratna, Professor C.N.R. Rao. It's a very difficult for me to express my feelings in words. It's a huge honor for me to receive this award. I deeply extend my humble gratitude to Bharat Ratna, Professor C.N.R. Rao and JNCASR for considering me to this prestigious award. A few years ago, when I started a blog named Bhimappa Bellar, I didn't have any idea that it could get this much of success. Till now, it has reached around 30 lakhs of views. This is the first science blog in Karnataka that has the highest number of views. In this blog, I provided secondary level science resources like chapter-wise notes, more than hundreds of PowerPoint presentations, videos, chapter-wise quizzes, animations in Kannada medium, free of cost, and helping the students, especially belonging to the poor community of rural areas. I'm also managing the Telegram group named Karnataka SSLC group, which has more than 10,000 students from various districts of Karnataka. I use this platform to share all my digital resources to the students and help them to achieve good results in the exams. We developed a smart class in the school with the help of community to provide a latest digital learning experience to the students of rural areas. Along with that, I use the school science laboratory to demonstrate the science concepts. I encourage my students to explore the laboratory and smart classes to get real science experience. I have also written more than 6 science books related to high school level, namely SSLC scoring package, Samasya Saraga, MCQ Kaipidi, Pariksha Payana, Kiru Pariksha Kaipidi, Vyatyasa Kaipidi, Chitra Sampada, etc. I put these books in the blog and are available to download totally free of cost. I worked as a content reviewer in Diksha portal and also working as master resource person in TALP and science subject trainings, and trained government primary and secondary school teachers in Raichur district. Once again, I would like to thank JNCASR for recognizing me to this award. I would like to dedicate this award to my family, friends, and all the students and teachers of Karnataka. Thank you one and all. Thank you.
Thank you, Shri Bhimappa, and also congratulations for the award. Now I request Dr. Ravi Prakash Sharma to give his response.
Thank you, sir. Akhandu mandalakaram vyaptam ene charachara nityavande padin tasmai Sri Guruve Namaha. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwara, Gurur Sakshat Parabrahma Tasmai Sri Guruve Namaha. Most honorable, renowned scientist, world famous scientist, Bharat Ratna, Professor C.N.R. Rao, C.N.R. Rao, Trustee Ma'am, and past presidents, Honorable Kulkarni Sir, President, and all other faculty of JNCASR, and respected jury members, friends, awardees, and all children scientists. I am very grateful to acknowledge this award, this prize to JNCSR. As I started my education from a village in Bareilly and started my career as a science teacher in Vishnoi Inter College, I found in the Article 51H Indian Constitution Act that 51AH scientific temper for knowledge. So I was being affected from it, and I started a science club in my school to make a scientific temperament among students. I participated students in National Children Science Congress, Rajya Vigyan Shiksha Sansthan Prayagraj, National Academy of Sciences Prayagraj, and many other local organizations in science exhibitions, competitions, and other co-curricular activities. Students won the recognitions at state level and international level, and I developed an aptitude among them to be a scientist, and some of the students became scientists in Bhabha Atomic Research Center, VRC, and ISRO, and other institutions, and they are in my regular connection. So they enjoy the field of research and science. Further, District Magistrate of Bareilly nominated me to UP government as a district science coordinator of District Science Club Bareilly, which is a non-profit organization. It is a network of Council of Science and Technology, UP government, and it has no honorarium, and it is social work for scientific population communication programs. I am District Science Coordinator, whose president is District Magistrate, and Vice President is Chief Development Officer, and District Inspector of Schools and Basic Shiksha Adhikari are the members of this club. First of all, I started my science journey in my school, and then I started this journey to whole districts to popularize the science. And many students were selected for Inspire Award. Do you know Inspire Award? Inspire Award, it started in 2009. It is a big program of Department of Science and Technology. Inspire means innovation in science pursuit for inspired research. And students of 6th to 10th class get 8,000 for their ideas of innovations, which can be performed for social utilization device. And their ideas are patented, and they get again many labels, state level, national level, international level. And at the Sakura program, they are joined to Japan. It is 5 days only selected, yes sir. 5 days they are placed in Rashtrapati Bhavan. So it is very important program, Inspire Award. Inspire Scholarship, Inspire Fellowship, other programs are related, so you can enjoy for the Department of Science and Technology. In the आज़ादी के अमृत महोत्सव में हम ऐसे बहुत सारे प्रोग्राम शुरू हुए हैं जो कि खासतौर से बच्चों के लिए, महिलाओं के लिए, वुमेन एम्पावरमेंट के लिए हुए हैं. उन सब पर फोकस करने की ज़रूरत है, जो रिसर्च संबंधित हैं. किरण प्रोग्राम है, तो यू कैन ऐड. तो मैंने जो स्टूडेंट्स थे हमारे यहाँ के, खासतौर से वुमेन्स थी, महिलाएं थी, उनको भी मैंने जो है उससे साइंस से कनेक्ट किया, और वो रिसर्च वर्क में जा रही हैं, उनको स्कॉलरशिप मिल रहे हैं. उसके बाद में देखिए कभी नया प्रोग्राम विज्ञान भारती, he started a program with the help of the Department of Science and Technology, Government of India, India International Science Festival. And I participated the students at different level in Kolkata, Delhi, Chennai, Lucknow, and many other places. Because the time is short, I could not tell more. Further, I am very grateful to all the faculty of here and Mr. who organized the program and hospitality to me. I was stay here. So I am very thankful to all of you, very grateful, and I dedicate this award to my college family and my district administration, my DIS, Dr. Mukesh Kumar Singh, and my staff. At last, Adhyapaka. So I would like to explain it. Tamso ma Jyotirgaman. Ajnanatam ki naas mein saksham rahe jo sarvada. ध्यान में बस ज्ञान गूंजे देश गौरव हो सदा. याद रख निज लक्ष्य को जो पूर्ण तन मन से करे. पठन पाठन धे थिर जग बीच मानवता भरे. कर्तव्य निष्ठा रहे सतत निज कर्म का वश ध्यान है. शिक्षक सदा जग में आदर्श और महान है. धन्यवाद मैम. जय विज्ञान, जय विज्ञान, जय अनुसंधान, जय हिंद. वंदे मातरम. भारत माता की, भारत माता की.
Thank you, Dr. Ravi Prakash Sharma, for your response, and congratulations to you and your family and your colleagues and students at your college. Now I may request Mr. Vidyadhar M. Yathgiri to give his response.
ಮೊಟ್ಟ ಮೊದಲಿಗೆ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ ಇವತ್ತಿನ ಈ ವೇದಿಕೆಯಲ್ಲಿ ತಂದು ನಿಂದಿರಿಸಿರ್ತಕ್ಕಂಥ ಈ ಪ್ರಶಸ್ತಿಯ ಸೃಷ್ಟಿಕರ್ತರಾಗಿರ್ತಕ್ಕಂಥ ಸರ್ ಅವರಿಗೆ ಹುಟ್ಟುಹಬ್ಬದ ಶುಭಾಶಯಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ ಅವರಿಗೆ ಕೋಟಿ ಕೋಟಿ ನಮನಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ ಇದ್ದೆ. ಮೊನೆಯ ಮೊದಲು ಪಾಠಶಾಲೆ, ಜನನಿ ತಾನೇ ಮೊದಲು ಗುರು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಇವತ್ತು ತಮ್ಮ ಮುಂದೆ ನಿಂತ್ಕೊಂಡು ನಾನು ಮಾತನಾಡುವಂಥ ಶಕ್ತಿ ತುಂಬಿದಂಥ ನನ್ನ ತಾಯಿಯ ಪಾದಾರವಿಂದಗಳಲ್ಲಿ ಪಡಮಡುತ್ತಾ ನನಗೆ ಮಾತನಾಡಲಿಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ. ತುಂಬ ಖುಷಿ ಆಗ್ತಾ ಇದೆ. ಅತ್ಯಂತ ಒಂದು ರಿಮೋಟ್ ವಿಲೇಜ್ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಅತ್ಯಂತ ಒಂದು ಸಣ್ಣ ಒಂದು ಹಳ್ಳಿ, ಅಂಥ ಹಳ್ಳಿಯಲ್ಲಿ 2003ರಿಂದ ನಾನು ಆ ಪಿರಾಪುರ, ಅದಕ್ಕಿಂತ ಪೂರ್ವದಲ್ಲಿ ಒಂದು ಬೇರೆ ಹಳ್ಳಿಯಲ್ಲಿದ್ದೆ. ಅಲ್ಲಿ ಮಕ್ಕಳು ಬಹಳ ಕಡಿಮೆ, ಒಂದು 20-30 ಮಕ್ಕಳು ನಾನು ಆ ಶಾಲೆಗೆ ವರ್ಗಾವಣೆಯಾಗಿ ಹೋದಾಗ. ಇವತ್ತು 416 ಮಕ್ಕಳು ಓದ್ತಾ ಇದ್ದಾರೆ. ಅಲ್ಲಿ ಓದಿ ಹೋಗಿರ್ತಕ್ಕಂತಹ, ಅಲ್ಲಿ ಈಗ ಓದುತ್ತಿರುವಂತಹ ಎಲ್ಲ ಮಕ್ಕಳಿಗೆ ಈ ಪ್ರಶಸ್ತಿಯನ್ನು ನಾನು ಸಲ್ಲಿಸ್ತಾ ಇದ್ದೇನೆ. ಯಾಕೆ ಅಂತಂದರೆ ನನ್ನನ್ನು ಈ ವೇದಿಕೆಗೆ ಕರೆತಂದಂಥವರು ನನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳು. ನಾನು ಒಬ್ಬ ವಿಜ್ಞಾನ ಶಿಕ್ಷಕನಾಗಿ ಆ ಮಕ್ಕಳಿಗೆ ಏನು ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಕೊಡಬೇಕಾಗಿತ್ತು, ಸರ್ಕಾರದಿಂದ ನಡೀತಕ್ಕಂಥ ಎಲ್ಲ ವೈಜ್ಞಾನಿಕ ಚಟುವಟಿಕೆಗಳಲ್ಲಿ ಮಕ್ಕಳನ್ನು ಅಣಿ ಮಾಡಿ ಅವರ ವಿಜ್ಞಾನದ ಸಂಗತಿಗಳು ಗೊತ್ತಿಲ್ಲದೆ ಇರತಕ್ಕಂಥ ಅಂತಹ ಗ್ರಾಮೀಣ ಪ್ರದೇಶದ ಮಕ್ಕಳಿಗೆ ಒಂದು ವೊಕ್ಯಾಬ್ಯುಲರಿ ಇರೋದಿಲ್ಲ, ಒಂದು ವಿಜ್ಞಾನದ ಪರಿಕಲ್ಪನೆಗಳಿರೋದಿಲ್ಲ. ಅಂಥದ್ರಲ್ಲಿ ಸಿಟಿ ಮಕ್ಕಳೊಂದಿಗೆ ಸ್ಪರ್ಧೆ ಮಾಡುವಂಥ ಮಟ್ಟಕ್ಕೆ ವಿಜ್ಞಾನ ವಿಚಾರಗೋಷ್ಠಿಗಳನ್ನು, ವಿಜ್ಞಾನ ವಸ್ತು ಪ್ರದರ್ಶನಗಳನ್ನು, ವಿಜ್ಞಾನ ರಸಪ್ರಶ್ನೆಗಳಲ್ಲಿ ಭಾಗವಹಿಸ್ತಕ್ಕಂಥ ವಿಜ್ಞಾನ ಪ್ರಬಂಧ ಸ್ಪರ್ಧೆ ರಾಜ್ಯ ಮಟ್ಟ, ರಾಷ್ಟ್ರ ಮಟ್ಟಕ್ಕೆ ತೆಗೆದುಕೊಂಡು ಹೋಗಿದ್ದೀನಿ ಅಂತಂದರೆ ಅವರ ಸಾಧನೆಯಿಂದ ಇದು ನನಗೆ ಬಂದಿದೆ ಅಂಥೇಳಿ ನಾನು ಅಂದ್ಕೋತಾ ಇದ್ದೇನೆ. ಅದಕ್ಕಾಗಿ ಮತ್ತೊಮ್ಮೆ ಅವರಿಗೆ, ಎಲ್ಲ ಅಲ್ಲಿನ ಊರಿನ ಜನರಿಗೆ, ಅಲ್ಲಿನ ಸಹಕಾರ ನೀಡಿದಂಥ ನನ್ನ ಸಿಬ್ಬಂದಿ ವರ್ಗಕ್ಕೆ ಅನಂತ ಕೋಟಿ ಪ್ರಣಾಮಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ, ಈ ಪ್ರಶಸ್ತಿಗೆ ನನ್ನನ್ನು ಆಯ್ಕೆ ಮಾಡಿದಂಥ ಎಲ್ಲ ಆಯ್ಕೆ ಸಮಿತಿಯ ಸದಸ್ಯರಿಗೆ ಅನಂತ ಕೋಟಿ ನಮನಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ ಇದ್ದೇನೆ. ಈ ಪ್ರಶಸ್ತಿ ನನಗೆ ಒಂದು ಗರಿ ಅಂತ ಅಂದ್ಕೊಳ್ಳಾರ್ದೆ ನನ್ನ ಹೆಗಲ ಮೇಲೆ ಈ 2 ದಶಕಗಳಲ್ಲಿ ನಾನು ಮಾಡಿದ್ದಕ್ಕಿಂತಲೂ ಏನು ಕೆಲಸ ಕಾರ್ಯಗಳಿದ್ದಾವೆ ಅದು ಬಹಳ ಕಡಿಮೆ. ಇಲ್ಲಿ ಬಂದು ಈ ವಾತಾವರಣ ನೋಡಿದಾಗ, ಇಲ್ಲೆಲ್ಲ ಗಮನಿಸಿದಾಗ ಇನ್ನೂ ನೀನು ತುಂಬ ಕೆಲಸ ಮಾಡಬೇಕಾಗಿದೆ, ಬರಲಿರುವ ಒಂದು ದಶಕಗಳ ಕಾಲ ನಿನ್ನ ವೃತ್ತಿ ಬದುಕಿನೊಳಗಡೆ ತುಂಬ ಜವಾಬ್ದಾರಿ ನಿನ್ನ ಮೇಲೆ ಹೊರಿಸ್ತಾ ಇದ್ದೀವಿ ಅಂಥೇಳಿ ಈ ಸಂಸ್ಥೆ ನನ್ನ ಮೇಲೆ ಬಹಳ ಒಂದು ಜವಾಬ್ದಾರಿ ಹೊರಿಸಿದೆ ಅಂಥೇಳಿ ಭಾವಿಸ್ತಾ ಈ ಪ್ರಶಸ್ತಿಯಲ್ಲಿ ಅನೇಕ ಸಂದರ್ಭಗಳಲ್ಲಿ ನನ್ನ ಮಕ್ಕಳನ್ನು ಹಳ್ಳಿಯಿಂದ ನನ್ನ ಮನೆ ಕರ್ಕೊಂಡು ಬಂದು ಅಲ್ಲಿಂದ ನಗರ ಪ್ರದೇಶಕ್ಕೆ ಬೆಂಗಳೂರು ಅಥವಾ ಮೈಸೂರು ಅಥವಾ ದೆಹಲಿ ಕರ್ಕೊಂಡು ಹೋಗ್ಬೇಕಾದ್ರೆ ನನ್ನ ಮಕ್ಕಳಿಗೆ ಹೆಣ್ಮಕ್ಳಿಗೆ ವಿಶೇಷವಾಗಿ ಅಲ್ಲಿ ಹೆಣ್ಮಕ್ಳು ತುಂಬ ಕ್ಯೂಟ್ ಇದ್ದಾರೆ, ಬಹಳ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡ್ತಾರೆ. ಅವರು ತುಂಬ ಚೆನ್ನಾಗಿ ಅವರು ನಮಗೆ ಏನು ಹೇಳ್ತೀವಿ ಅದಕ್ಕೆ ಸ್ಪಂದಿಸ್ತಾರೆ. ಅಲ್ಲಿ ಪಾಲಕರು ಕೂಡ ನಮ್ಮ ಮೇಲೆ ಅದಕ್ಕೆ ನನಗೆ ಇದನ್ನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಅದಕ್ಕೆ ಅಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಅವ್ರಿಗೆ ಊಟ ತಿಂಡಿ ಮಾಡಲಿಕ್ಕೆ ನನ್ನ ಶ್ರೀಮತಿಯವರು ಕೂಡ ಈ ಸಂದರ್ಭದಲ್ಲಿ ನನ್ನ ಸಹಕಾರ ನೀಡಿದ್ದಾರೆ. ನನಗೆ ಕೋವಿಡ್ ಸಂದರ್ಭದಲ್ಲಿ ಆನ್ಲೈನ್ ಪಾಠ ಮಾಡುವಾಗ, ಆನ್ಲೈನ್ ಕ್ವಿಜ್ಗಳನ್ನು ಮಾಡುವಾಗ, ಹೀಗೆ ತಾಂತ್ರಿಕವಾಗಿ ಬಿಲ್ಟಪ್ ಮಾಡಲಿಕ್ಕೆ ನನ್ನ ಮಕ್ಕಳು ಕೂಡ ನನಗೆ ಅಲ್ಲಿ ಆ ಸಂದರ್ಭದಲ್ಲಿ ಸಹಾಯ ಮಾಡಿದ್ದಾರೆ. ಈ ಪ್ರಶಸ್ತಿ ಹಿಂದೆ ಅನೇಕ ಕಾಣದ ಕೈಗಳಿದ್ದಾವೆ. ಅವರೆಲ್ಲರಿಗೂ ಈ ಪ್ರಶಸ್ತಿ ಸಲ್ಲಿಸಿ ನನ್ನ 2 ಮಾತುಗಳನ್ನು ಸಮರ್ಪಿಸ್ತೇನೆ. ಧನ್ಯವಾದ.
ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಮಿಸ್ಟರ್ ವಿದ್ಯಾಧರ್. ತುಂಬ ಧನ್ಯವಾದಗಳು ಹಾಗೂ ಶುಭಾಶಯಗಳು. So now I request our President, Professor G.U. Kulkarni, to give his remarks. Sir.
Good morning to you all. Respected Professor C.N.R. Rao, Dr. Mrs. Indumati Rao, Mr. Sanjay Rao, and other trustees of the C.N.R. Rao Education Foundation, Professor K.N. Ganesh and family, teacher awardees present here. Quiet please. Hello. Professor Krishnan, Professor M.R.S. Rao, Professor Nagaraja, Professor Narayan, Professor S M Shivaprasad, Director of the Karnataka Higher Education Academy, Dharwad, faculty colleagues, and teachers and students. When I say teachers and students, not only those who are here, but also I was told that there are many, many schools who are participating in small groups in various halls. Mr. and Mrs. Ishwar from Chandana, many others. So many are participating online, so all of them I would welcome, and also urge that those who are staying online to visit the center and also get associated with us wherever there is opportunity. Thank you, Professor Govindaraju, Chair, Education Technology Unit, for the invitation. Thanks also to Mr. Jayachandra and Mr. Vinayak Pattar for their coordination. Let me begin by wishing Professor C.N.R. Rao very happy birthday. It's a very special occasion for all of us in the JNC family. We truly feel honored to actually I received a message from Honorable Prime Minister of India, Shri Narendra Modi ji, and let me take this opportunity to read out the message itself. Pradhan Mantri, Prime Minister, New Delhi, Ashad, Shak Vasant 04-1944, 25th June 2022, Dr. C.N.R. Rao ji, my heartiest congratulations and best wishes on your birthday. Dirghayur arogya mastu, suhasha bhavatu. May you live a long and healthy life. May you succeed at every step in life. May the joy and auspiciousness of the occasion fill you with fresh energy and enthusiasm to further the cause of nation building. Praying for your continued good health and well-being in the years to come. With warm regards, yours, Narendra Modi. The letter is addressed to Dr. C.N.R. Rao, Jawaharlal Nehru Centre for Advanced Scientific Research, P.O. Jakkur, Bangalore, Karnataka, 560064. The letter ends. Well, I'm glad to be here with you all on this wonderful, momentous occasion, and it's truly a privilege and an honor to be associated with this activity, Teachers Award activity. I thank Professor Rao, Madam Rao, and the C.N.R. Education Foundation for making this award function happen annually. in spite of all the challenges of the pandemic. The foundation, as we see, has been making great efforts to promote good quality science education by way of conducting several science outreach programs throughout the country. My colleagues mentioned about it, especially reaching out to the rural young minds. And as part of this activity, the foundation also recognizes dedicated science teachers at school and pre-university levels, and this truly noble initiative motivating the school teachers. For the last 16 years, under the aegis of CNR Education Foundation in association with JNCSR, this program has been running successfully. 36 talented science teachers, including the ones who are around here from the 2020 and 21 awardees, have been identified and awarded thanks to the jury. And usually this award function is followed by a popular science lectures addressing students and teachers. This time we have Professor Shivaprasad and others. On behalf of the center, I congratulate the 2020 and 21 awardees, namely Sri Bhimappa, science teacher, Government Girls High School, Raichur, Dr. Ravi Prakash Sharma, lecturer, Vishnu Inter-College, Bareilly. These are 2020 awardees, and Mr. Vidyadhar N. Ettagiri, science teacher, Government High School, Vijaypura, 2021 awardee. Hearty congratulations to all these awardees and also their family members. So on behalf of the center, I would like to thank once again Professor C.N.R. Rao and Madam Rao for their visionary efforts towards popularization of science in India through such initiatives. And I must say the center will continue to support such activities in the future as well. Thank you very much.
Thank you very much, sir, for your kind remarks and also support for all the activities here. Now we have come to the end of the program. I request Vinayak Pattar to give vote of thanks. Vinayak.
Thank you. Thank you, sir. We express our grateful thanks to the CNR Education Foundation for entrusting the Jawaharlal Nehru Centre for Advanced Scientific Research in the selection of Outstanding Science Teachers Prize awardees for the year 2020 and 2021. Yeah, sorry. Our thanks are due to the award selection committee members for helping us in the selection of the awardees. We express our thanks to all the Outstanding Science Teachers Prize awardees for their kind presence. We thank all the invitees for the gracing this function who are present online and you in offline. Our sincere thanks to the President of JNCSR, Professor G.U. Kulkarni, for felicitating the awardees and extending his support for the organizing this particular event. We wish to express our sincere thanks to Professor C.N.R. Rao, Dr. Indumati Rao and family, and all the governing council member of the CNR Education Foundation. We thank the administrative officer and administration for providing the infrastructure facilities to host this event. Finally, I thank the technical team for making this event successful without any technical glitches. Thank you all once again. Now, we'll have a short tea break, and I request online participants to stay tuned. And we have a wonderful lecture from eminent scientist and educationist, Professor S M Shivaprasad. It is a very wonderful, you will enjoy it, each and every moment of that lecture. And we'll be back here very soon. Okay? We'll start a little bit early, if you have the tea very quickly. Yeah. Thank you very much. Then now the dignitaries will leave. Then afterwards, you take the back door. Okay? Come here, the volunteers will guide you. Yeah. Only 10 minutes break. Yeah. Yeah.
ಏನಿಲ್ಲಲ್ಲ.
Okay, I'll ask you one question. Okay, already, do you know what is the speed of light? Huh? 3 lakh kilometer per second. 3 into 10 to the power of? Okay. 3 lakh kilometer per second the light will travel. Yeah. Okay, now we'll start the event now. I request Dr. Pratap Vishnoi to introduce our speaker, Professor S M Shivaprasad. Please, sir, over to you.
Thank you, Mr. Vinayak, for inviting me to introduce opening speaker of this very special event and my own colleague, senior colleague, Professor S M Shivaprasad. Truly, I feel very honored to introduce him in this gathering in the august presence of Professor Rao, Madam Rao, and their son, Mr. Sanjay Rao. Thank you, sir, for being there to inspire us. Professor Shivaprasad is a professor at the Jawaharlal Nehru Centre for Advanced Scientific Research, Bengaluru, since 2007. And he is also a director of Karnataka State Higher Education Academy at Dharwad since 2017. Before joining JNCASR as a professor, he was a senior scientist at the National Physical Laboratory at New Delhi for a couple of decades since 1985. He did his PhD in physics from Karnataka University at Dharwad in 1982, and then he did postdoctoral work at the IIT Delhi, followed by Commonwealth postdoctoral fellowship at the University of Sussex, UK. He has worked as visiting scientist at various institutes, including NIST, USA, Rutgers University at USA, and Ulm University of Germany, and Tohoku University of Japan. He has contributed very significantly to scientific research with research publication over 300 in international scientific journals, as well as 3 monographs which he edited or authored. He is a recipient of many significant awards and fellowships. In the interest of time, I list some of them, the prominent ones. He's received CSIR Young Scientist Award from the President of India, Dr. Rajaramana Karnataka Government Senior Scientist Award, the Materials Research Society of India Medal, Superconductivity and Material Science Prize from the Materials Research Society of India, CNR Rao Oration Award, and Outstanding Scientist Award from CSIR. He is also the Vice President of the Materials Research Society of India. With this brief introduction, may I kindly invite Professor Shivaprasad to deliver his talk on beauty of science and the science of beauty. Please.
Good morning, all. So, sweets alla chanagitta? Yeah? Okay, I love that sweet. Okay, so I'm sure you also did. First of all, I think what I should do is congratulate these 3 wonderful people, the great teachers of science. Yeah, very nice. And then let me start my presentation. Yeah? Okay.
ಸ್ಕೂಲ್ ಚಂದನ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಒಂದು ಸ್ಕೂಲ್ ಇದೆ. ಪ್ರೊಫೆಸರ್ ರಾವ್ಗೆ ಆಮೇಲೆ ಮಿಸಸ್ ರಾವ್ಗೆ ತುಂಬ ಇಷ್ಟ ಆ ಸ್ಕೂಲು. ದೆನ್ ನೋ ದಟ್ ಸ್ಕೂಲ್ ಎವ್ರಿ ಇಯರ್ ದೇ ಸೆಲೆಬ್ರೇಟ್ ಪ್ರೊಫೆಸರ್ ರಾವ್. And the school kids they speak English very fluently. It is a very small village in the North Karnataka. Okay, and those kids speak English the more than what they speak in Bangalore. Those comments. You can see.
Today we are celebrating birthday
ಇದಲ್ಲ. Okay, okay. Thank you. Thank you. Good morning, friends. We'll talk about something very, very interesting we talk about every day in our life, right? Beauty. Before I start what is beauty, let's see this picture. Yakpa. This is the beauty of giving a talk. Yeah, okay, right, beauty of technology, right? So anyway, so keyboard hitkondu addutra ille barla. Okay, look at this picture. Isn't it a beautiful picture? Yeah, see, I don't know, I mean, some of you may have seen Professor Rao earlier. Okay, we have been seeing him, etc. The most beautiful smile comes when he meets the children around, right? See, all the boring people who are standing behind. Okay, so he doesn't get that smile when he meets them, but look at this beautiful smile he gives when he meets children, and that's what I think what Professor Rao is. So we are all very, how do I say, blessed by his presence. Each of us have grown in life because of his blessings, and but as you know, he blesses you more, right? So it's a wonderful occasion today to meet, to get together and celebrate his birthday. And we know that all of you should also be ready. We will also celebrate his 100th birthday, and maybe the 150th birthday, and maybe the 200th birthday. Okay, with this, I'll start telling, okay, showing something. So first of all, students of your age should understand the difference between science, technology, and engineering. Okay, usually we think they're all same, but that's not true. They're all three different things, right? Science is about discovering new things, right? Understanding nature, inspired by nature, and you want to understand nature, how nature works. That is science. And this is dominated by the question why. You keep asking, for everything you ask, why? Okay, irritate everybody by asking why. And that is the way to become a scientist, right? Asking the question why. The next is, so the scientist finds something in nature, he plots it in a graph or an equation or something. And ultimately you have this technologist who looks at this graph, he takes, oh, this fellow says this fellow says this. So let me put together and make something useful, like this remote control, for example. So the concept of how to make this technology together, I mean, bring those ideas of science together, is the technologist. And then somebody has to make this, right? Just thinking about it doesn't help. And the persons who make this are called engineers, right? All are three very, very important things. But each of you need to identify which inspires you a lot. I'll show you some pictures of scientists, right? You understand? Who are these? Somebody can tell me? You know all of them? Yeah? Amazing scientists. These were scientists, right? They're just curious about nature. They're not trying to do something useful. They're curious about nature and to understanding nature. And these are people, okay, if you can read it. Can you read somebody? Yeah? These are technologists, right? Please understand. And a couple of famous people who are engineers, right? So, you know, common man keeps saying, call everybody a scientist. But you, as students of science, should understand the difference, right? Very important for all of you. Yeah, we'll start with this. Then see, what is this? What are these things? Nature. Why do you like to see such things? You like to travel and see such things. Why do you want to see such things? Why do you want to see something? Why do you want to go and see something like this? Yeah? Because it's beautiful. Right? It's just their pictures are so beautiful, and that's why we love to see this. But what is beauty in this? Do we understand what is beautiful? Let's see another picture. See? Amazing nature produces so many things which are also very, very beautiful. Don't they look beautiful? Yeah? Now I'll ask the boys here. Okay, who is beautiful? Yeah? Now let me also ask the girls who are handsome here. Yeah. So please understand, okay, what is beauty? Right? This question is one of the most important questions in life to ask, what is beautiful? Right? You decide, all the girls decide who is the most handsome guy. Okay, okay, what do you call? Hunks, right? It's called, yeah, okay. Okay, and you boys decide who is more beautiful. Let me tell you this picture, these are all pictures of robots. They are not real human beings. These are pictures of robots. So you understand, so now how did they make all the robots look so beautiful? Right? See, you see this, very interesting, right? So these are all robots. So the idea is, somewhere we know what is beauty so that we can make something beautiful. Right? So first we'll talk about the beauty of science, and then we'll talk about the science of beauty. Right? Let's go ahead. Okay, now see here. So ultimately somebody says there are so many definitions of Marie Curie, Kush, and then here, but the ultimate true definition of science is the study of the beauty of nature, of the world. That is the definition of science, not physics, chemistry, mathematics. They are all side business. Right? Main business is to understand the beauty of knowledge. Okay, now let's go hard. So look at this beautiful girl, very pretty girl, right? One of you, few years ago, you were like that. All of you were like this. So what she did, she was walking on the lawn. She saw some small flower, something. And old people like us, we go on stepping it and don't bother about it. But that girl went back home, brought a magnifying lens and started seeing what it is. How is this like this? How is it? So the curiosity she has is the most important thing. The curiosity is the most important thing for science. So the idea is, don't study physics, chemistry, everything. Okay, don't study, they're not important. Exams are not important. What is important is, find out what you are curious about. The whole effort of life, okay, is to find out what you are curious about. That is very important. So all this, and then of course, then Einstein says, once you are curious, then you start imagining things. You all imagine so many things. You see so many dreams, right? We all imagine things. But that imagination is the most important thing. You know, Einstein was a very bad student when in school. When he was your age, he was a horrible student, right? And at 18 years old, he was a bad student. All of you were scoring much better marks than he was doing it. But at 29, he became one of the greatest scientists in the world. Probably in the history of mankind, he is probably the greatest scientist. How did this happen? How such a bad student in school became great scientist, right? So he says very beautifully, one sentence I just want to share before I go ahead. Einstein said, I was a fish and the school wanted me to climb a tree. You understand? I was a fish and the school wanted me to climb a tree, and so all my schooling, I thought I was stupid because I cannot climb a tree. You understand? So we are all different. Each of us are different. We have one examination, one syllabus, one teacher, one boring teacher, one stupid fellow. I mean, all these things are there. But what is more important for you is to understand yourself. That is very, very most important. And the whole role of all the teachers sitting here is not to teach physics, chemistry, mathematics. It is to make you understand yourself. Okay, that's the purpose of life, of science. So now see, so you started with curiosity, okay, and then you started making observations. Then you ask small questions about that, your curiosity. Hingyaka. You start asking these small questions, then start imagining the answers for that, several imaginations for one answer, and ultimately you start getting the big answers. Small questions will lead to big answers. So friends, the ability of being students of science is not to remember what is in the syllabus or the book, but to have the ability of asking the questions. Einstein again said, in my school, I was asked to give answers to the question which teachers asked. I did not get an opportunity to ask my questions. So after school, finishing school, I asked my own questions and found my own answers, and that is how I accomplished something in life. So, friends, creating this curiosity, asking questions, imagination, okay, these are the important aspects of whatever you do in science. Isn't it beautiful? Science is so much more beautiful, and we'll talk about it a little bit more. So look, this is a picture which inspired me. One day I was walking when I was young, like you, in the university library in Dharwad. Okay, I was walking there and found this picture, and I said, okay, what is this? A galaxy, picture of the galaxy. But what surprised me or shocked me is this part. It said, our Milky Way galaxy is somewhere here. Somewhere here. Then I got very curious. Okay, until that I was also by-hearting everything. But this picture started making me think differently. Our galaxy is somewhere here. We can't place it, the whole galaxy. And how big is the galaxy? I'm sorry. How big is the galaxy? 26,000 light years diameter. And that in this universe is somewhere there. Imagine. Imagine what it means, right? So, okay, to see this, I'll show you a small video for 2 minutes. Okay, it's all in the WhatsApp. I'm sure some of you must have seen this. But just for some people who have not watched it, please play the video. Yeah, look at the scale here. I just want you to concentrate on scale. There's a beautiful girl, and now we'll start seeing her from far away. From 1 meter, 10 meters, okay, 100 meters. Sorry for the quality. 1 kilometer, 10 kilometers, from 100 kilometers, 1,000 kilometers, 10,000 kilometers, 1 billion kilometers. Start seeing the solar system, right? 10 million kilometers, 1 billion kilometers from far away. We are going away. Yeah, you can imagine seeing that beautiful girl. She's lost, right? She's lost because the beauty of nature takes over, right? It's the beauty of nature. 1 light year means about 1 trillion kilometers, 1 billion kilometers, and then 100 light years, 1,000 light years. Look at this, 10,000 light years. 1 million light years. Imagine the size. Okay, please think about the size we are talking about. 100 million light years. 1 billion light years. So we see up to there. We know up to there. We'll come to that in a little bit point. Now let's go back and see that girl. We make the return journey, right? Start seeing the earth. Come back. You were all in a spaceship, right? Went away. Now you're coming back to the world. Yeah? So now you see this beautiful girl. Now you start going inside her. Now I see 1 millimeter, 100 micrometers, 10 micrometers. You start seeing the white blood corpuscles. 1 micrometer, the DNA starts. You see the DNA. 100 nanometers, the details inside the DNA. 10 nanometers. Okay. Then 1 nanometer means your 10 angstroms, and then 1 atom. Inside the atom, 10 picometers, the nucleus. Right? Think about this. Okay. 100 femtometers, 10 to the minus 15 meters. Okay. 10 femtometers, 1 femtometer. Then go to the quarks, up to the quarks. Okay, please stop the video. Okay, is it very interesting? Right? It's a very inspirational video. Right? What it shows is something I'll show next about another story of Einstein. We should remember Einstein this year at least because it's the 100th year of him getting the Nobel Prize. So I'll tell you stories about a little bit of Einstein several times about the stories. Please, amazing scientist. Okay, many questions. So once Einstein visited the Mount Palomar Observatory telescope, large telescope, 200-inch telescope. In those days, that was the largest telescope. Now we have Hubble and other telescopes, but this was the largest telescope. So he went, and Russell Porter was the scientist there who took Einstein around and showed him this. Einstein is coming. Welcome. Yeah. Okay. Right. Okay. So you see here. So 200, and Russell Porter said something very exactly like the picture we talked about. The picture we talked about, he said, Professor Einstein, I've been seeing stars for the last 40 years. One star after 1 million kilometers away, 1 billion kilometers away, light year, I mean, all the things. And then in this whole huge universe, there is an extremely tiny galaxy. In that galaxy, there is a tiny solar system. In that tiny solar system, there is a tiny Earth. In that tiny Earth, there is a tiny country called India. In that large country called India, there is a tiny place called Bangalore. In that large city called Bangalore, there is a tiny place called JNCASR. And inside this large campus of JNCASR, there is a tiny auditorium. In that auditorium, one stupid fellow is standing. Right? You see this, what he said, Russell Porter, was how insignificant life is. Whether we exist or don't exist, does it matter to this universe? Right? Sometimes I'm walking, I'm stepping on some ants. Okay, it's going, but world, does it change? So he says, is it really worth doing science? He asked this question to Einstein. Is it really meaningful to do science? So Einstein replies very beautifully, let me tell you. He said, I agree with you, Russell, that we are so small. But isn't it wonderful that we know that we are so small? You understand? See, that we can see up to 1 billion. See, all are approximately, we are 5 to 6 feet tall individuals. Sit here on this earth and understand what happens, okay, at that distance. That is the beauty of existence. That is the beauty of human science, I mean, human existence. So we are all alive here to see this beauty of how small we are. Right? And then he goes on to say, but you know, Russell, you also know there are atoms, there are electrons, there are protons, there are quarks, and compared to them, we are so large. Right? We can be so proud that we are so large. Right? So he says, the beauty of human existence is to know that we are both very small and very large. Very large to be confident to say, I can do so many things. And very small to say, my God, I should be humble. So the idea, friends, is to develop that ability to do your best you can while you are humble. And that is the character of Professor CNR. You understand? No claps? Yeah? Yeah? Right? These are the important things. This next picture, again, C.V. Raman. He says very beautifully, ask the right questions, not to find answers. Okay, you don't need to find answers. You have to ask questions. That ability of questions is the beauty of your existence. Okay, we'll go ahead. This is Cosmos, right? This is a beautiful book by Carl Sagan. If you get a chance, please read this. Of course, it was in the 1980s when I was young. Once upon a time, I was also young like you. Okay, so this beautiful book, Carl Sagan is a great narrator. There are also YouTube lectures, everything you can see that about the cosmos. Okay, like we are very proud of Aryabhatta, right, who contributed so much to the knowledge of this world. And then Galileo Galilei, right? And these are the people who try to understand nature. Right. So this guy asked this one stupid question. Why does the apple fall down? In his grandfather's time also apple fell down. In his father's time also apple fell down. And this fellow, when he was young also it fell down. But when he became a professor in Cambridge, he was trying to understand Galileo Galilei, to understand how the planets orbit around the sun, and he was engrossed in that thought. When he was engrossed in that thought, right, then when the apple fell, it occurred to him. Right? It occurred to him, why is it falling down? Why is it not going up? That you all know became historical. Right? So you see here, everything, all these things run on those Newton's laws of motion. Right? This all beautiful thing happened because he was not interested in making a satellite or a plane or anything. He was just curious to find out why apple fall down. That is a scientist. He doesn't try to make something useful. He just wants to curious. Like we are also interested, no? Why that boy is going around with that girl? Yeah. Why the husband and wife are fighting in the neighbor's house, in your neighbors? Okay. These are also the curiosities. That's also very interesting, very challenging. But slowly, if you change the direction of this curiosity towards understanding nature, okay, you will become a scientist. Right? That's what they said. People who have become scientists have told me, I have not become a scientist. But there are so many beautiful things which are there. Then came this guy. Okay, who could not? He started thinking, if I walk like this, I'll see some nice pretty girl, somebody wearing mask, and the ladies with their beautiful saris. Okay, our Ishwar, right? You all see. But if I walk fast, somebody is sitting here, somebody is sitting here, right? And if you go even very faster, something was happening, you don't know what happened. So, this fellow asked the question, if I sit on light, you were telling the answer when he asked the question that it goes at 3 lakhs kilometers per second. He started asking this question, okay, how will the world look if I travel on a ray of light? You see, beautiful, no? What happens when I move at that speed? How will this world look? And that gave rise to the theory of relativity. Right? That question, that simple question. Right? And then, of course, now theory of relativity opens a big box of knowledge, information. I mean, the gravitational waves, this, I mean, everything you can. He actually proved that Newton was wrong. Right? Very interesting. And that is the beauty of science. You can always be proved wrong while you still respect the person who was wrong. Because it is only in some region things change. Anyway, I don't want to go into the detail, but just tell you, that is the beauty of science. It keeps changing without hurting any ego. Right? That is very important. Now you see here, this one, you look at this, it's a beautiful blue sky, and sometimes the sky is red. Sometimes it's blue, sometimes it's red. Why is this? Then this fellow asked this question. Why is the sky blue? He asked this question, why is the sky blue? Then he realized, the atmosphere does it. Again, I don't want to go into details, but beyond the atmosphere, sky is black. Only the atmosphere makes it blue. Why does it make blue? Because he found out that the blue light has a smaller wavelength, and so any particle in the atmosphere, it will scatter. Instead of going, if it is coming like this, the particle will come like this, it's small wavelength, it will dash, and then it will change its direction. It will go like this, right? When it goes like this and hits other particles, they started looking blue. Other wavelengths, like this one, the large wavelength, red color is a large wavelength, other colors, so they miss the particle. So they come to our eyes. And so blue light remains in the sky. Some part of it, not all of it, some part of it. And that is why the sky is blue. Now, homework for you. You have to send me by email at the end. Why is the sky orange and red in the evening? The same logic you should be able to explain. Why? Another question. Why do we have red light for stop signal? Red light for danger. Okay, sorry? Yeah, very good, very good. Think about it. But why is the, very nice, but why is the sky orange in the evening? Is it lot more? Same is from the sun. How do you make a difference here? There is no difference. Right? There is no difference in length. Right? There is something else. Think about it. I don't want to give an answer. You think about this. And at the end, I'll give my email. Write to me your answers. Okay. Then probably I'll learn some new things from you, which is very important. Okay. So now, then this fellow said, our own fellow, C.V. Raman, right? The person who inspired C.N.R. Rao to become a scientist. Okay. C.V. Raman. Okay. He heard one lecture. Professor Rao keeps telling, I heard when he was in school, C.V. Raman came to his school and gave a lecture. Okay. And he said, I did not understand anything about the lecture because it's at that level. But I felt I should become like him. He's that confidence, that ability, that knowledge. Etc. He inspired him. Right? That is how it is. Please keep watching these great people. Somewhere you will get inspired before you get expired. Right? It's very important. So, friends, you inspire yourself. Don't wait for us stupid teachers like you and me, all of you, to inspire you. You have to inspire yourself. That, I think, is a very, very important thing to see. So this fellow asked this question, if the sky is blue, okay, he told us how the sky is blue. But now why is the sea blue? Water blue? Then he wrote a letter to somebody, to another scientist who was working on this, and asked him, why is the sea blue? Then probably, and he showed, even Lord Rayleigh, who had found out that the sky is blue, had written somewhere that probably it is a reflection of the sky in the water. But Raman said, no, it can't. There is something else to this, right? There's something else to this, because when it goes through molecules, it does something else. That was scattering, what we call as inelastic scattering of light. Light comes, hits and goes this side without changing its energy. So we call it as inelastic scattering. But here, he said there is something else. Then he started asking, dreaming about it, imagining about it, thinking about it, discussing about it, reading about it, understanding about it. Okay, and then he started doing this research to understand why is the water blue. What happens when light hits a molecule? It was very simple. You see that particle is sitting there, this wavelength came, hit and scattered. So now Raman started thinking, oh, the particles are not quiet, right? They are moving like this. Like this is water, for example, water molecule. That means they are moving like this. So what happens? I love that. She is trying that, very sweet. Okay, so you see here, if this is moving like this, my light comes and hits, what happens? If it is moving like this, what will happen to the energy of this molecule, photon which hits it? It will reduce or increase. It is moving like this and you are hitting from here. It will reduce. But if it is moving like this, it will gain energy. So this is what Raman said, that when the photons travel and hit a molecule, it depends on the vibrations, rotations, and the translations of motion that you will get a change in wavelength. That's all he said. And he got a Nobel Prize for that. Simple, he just said, if it is moving, it will change its energy to energy. These are called in Stokes and anti-Stokes. And he performed this experiment in this 130 rupees equipment. 130 rupees equipment. At that time, of course, it may be a little bit more. But that time there was no spectrometer, no nothing, etc. So, but he said, once I remember, one some scientist from UK had come, and I'd taken him, I went with him to Professor Rao, meet Professor Rao. And ultimately, after meeting Professor Rao, he came out. Okay, and while he was coming out, he said, Ram, they call him, all his friends call him Ram. Hey, Ram, you don't have any system in your office. No computer, no laptop, nothing. So Professor Rao replied very beautifully, yeah, I have a brain. Yeah. So that is the beauty. So this went on. Now it has become a very big field, Raman. After the lasers start coming, now they were not only able to do liquids, Raman spectroscopy, now you can do also for solids. And that has revolutionized everything. Now with nanotechnology coming, something else has come, which is called a surface enhanced Raman spectroscopy that even takes it even further, makes it more beautiful. Okay, we'll talk every slide. I will require about 2 hours to speak. Okay, so today This session will end at 8 o'clock in the evening. Okay? Okay, yeah, now, and this fellow asked this one simple question, how can birds fly? He went on doing this, he could not fly. But the birds were able to fly. What happens? Right? He asked this simple question. And then he found out this answer that you have to create a pressure difference. How fast you have to flap? You have to create a pressure difference between above that wing and the below that wing. If you create, the pressure is lower here, okay, higher here and lower here, it will lift. That's all he found out. That is called as the Bernoulli's theorem, right? And now our shape of the wings of the airplane are like this, and you see here, now you can do amazing, huge aircraft flight. Not only things, people who are interested in cricket, you know something called as reverse swing? Okay, it happens because of Bernoulli's principle, right? There are only some people who can swing it, right? They make the surface of a ball one side rough, so that the air sticks on longer, the pressure increases that side, and the other shining side, okay, the pressure is less, and so it pushes the ball in this direction. So you can swing the ball in one direction, and the ball after falling will go back, and that's what we call as reverse swing. That also is based on Bernoulli's principle, right? So, and now this guy asked, all of us look like this in the morning once, yeah, we all look like this. But he came out by saying Eureka, Eureka. We come out by saying Areka, Ereka. Okay, some Reka. Imagining our Rekas, right? So, and that will decide your Reka of your hands, right? The future depends on which Reka you are looking for, Eureka or Reka, right? So you see here, he was challenged to say, how do I can find the purity of materials? And he said, when you find the purity of materials, at that time there were no spectrometers, there were no devices, nothing, and he had to find out. He was thinking about it, just like Newton was thinking about something else. So he was thinking about it, then he always thinking, and he went into the tub. And water came out, right? Especially somebody like me, 100 kilos, if I go, a lot of water will come out. Okay. Also my friend Pratap, we can put a lot of water out. Yeah. Then he started asking this question, okay, if Madam goes, less water comes. If Pratap goes, more water comes. So what is this dependent? Right? He tried to find out, did simple experiments to understand what do you put in, how much does it depend on the volume, on the mass, on everything he tried to understand. And then he came out and said, I can calculate density of a material accurately. And that's what he did. And he could actually find out in the king's crown how much copper was added by the goldsmith. Cheating, right? The cheating. So that time there was no idea of how to measure it. But he was able to do that. And then came the concept of buoyancy. Right? That is the concept of buoyancy. I and Pratap, we feel very happy when we go into the swimming pool. Because you'll feel lighter. Right? Because of buoyancy. Okay, that's what it is. Now the question is, using that concept, we can make huge ships. If you design, you can make huge, amazing, 3,000, 4,000 people inside, cars inside. Now planes come and land on that. Okay, all these beautiful things can happen because of the concept of buoyancy. He never planned to make a ship. He was just curious to understand something. Right? That is the whole idea, is to become curious. Now you see this guy, he asked this question, why am I better than my father and mother? If you tell this, your father and mother will not agree. Okay, the answer, I asked this to my father, I told him I'm better than you. Then he asked, how do you say? Okay, then I said, because you are more closely related to the monkey than I am. And one generation ahead of you, right? So obviously chill. And this question led to Charles Darwin's theory of evolution and the beautiful book called Origin of Species, which came out with this beautiful thing by Charles Darwin. Okay, I have to go a little bit. Next is, why do we look like our parents? If we don't look like our parents, there is a big danger. Especially if you look like your neighbor. Okay, very, very important. Okay, so he asked this question, why do we look like our parents? Then Gregor Mendeleev worked on heredity. At that time, there was no idea of DNA or anything of that sort. He took pea plants. Yeah, any questions in the back? Yeah? If you have something to say, please let us all share. Don't talk to your friends. You can talk to them later. Okay, if you have something, stand up and say, I'll be so happy to learn something from your questions. Okay, that is the whole idea. Okay, now this fellow asked parents, then he did on pea plants. He took millions of pea plants, he studied them, measured when they grow, their height, their length, and that, and this, and everything, and came out with this philosophy of the Mendel's principle of heredity. Okay, now with the DNA, other things which have come all based on this one, and now we know human migration, where life started, where people moved, why we are of different forms, etc., is decided by this beautiful discovery, one question. And here, this is the story from Kanada Rishi, okay, to Louis de Broglie. See, the question is, they started thinking, if I take a chalk piece or take this pointer and break it, I'll not do that, don't worry. Okay, so go on breaking it very small, what it will become? So Kanada Rishi called it as Anu, right, Anu. But later, Democritus, another 400, 500 years later, okay, he found out that each material have different Anu, elements, what we call now as elements. And then went on the story, okay, which I will not go into the story, and you see now atom looks like this, not like this, not like this, not like this, atoms look like this. See, and now we know, we don't even know whether the electron is a wave or a particle, right? Sometimes you hear like a wave, sometimes, when teacher taught me this in my college, I thought my teacher is stupid, or the scientists are stupid. They can't say whether it's wave or particle, what kind of education they have. Right? But I later realized it's one of the most profound questions of the world of science. Okay, this is something very inspiring. You could all think about this, how it manifests in different forms. Okay, then this double-slit experiment, one of the most important experiments in history, which gave rise to quantum mechanics, and then you get these complicated things called as wave function, electron orbits. Now you know how they are, different orbits, of what shape they are, etc., etc. So we clearly know that it is not like we think that these are similar to the orbits in the periodic table. But it is not like that. That is completely different based on theory of relativity. And this actual picture of the atom, which may be like this or something like that, is now a very different picture. Right? It's for a different reason, because electrons are waves. The wave mechanics leads to different form. So we always, when we are children, we are confused. Na? Planetary system is also like that, atom is also like that. No. It is completely different. If it was like that, all electrons would have fallen into the nucleus and there would have been no existence, no world, right? So this has been possible because of this question. Okay, and then you have Gregor Mendeleev. You should hear the story from Professor Rao and Mrs. Rao, who talk about Gregor Mendeleev, etc. I have 5 minutes, so I've just started my talk. Okay, yeah, okay. So anyway, so these are something like that. So now, and then once you found out about atoms, then you wanted to find out how they bind with each other. And a lot of work by Linus Pauling, again another inspiration for Professor Rao. He studied that book, okay, the chemical bond, okay, and that Professor Rao, he says he was inspired, he understood real chemistry by doing this one. Okay, so now large molecules, then DNAs, then our own G.N. Ramchandran found that the triple helix model, everything, so many complex. Now we know everything is a protein. The COVID is a protein, body, everything is a protein. So how do we understand proteins is all a beautiful thing. What are the bonding? How do the electron transfer from one place to other? It makes it very exciting. Okay, right. So now here we had nanoparticles. I'll jump all this part because of time. I'll just show last part. Okay, again, I just want to tell you, this guy asked the question, why are leaves green? And found out what is photosynthesis. And then now people are working on artificial photosynthesis. Professor Rao has contributed enormously to this field, to how to do photosynthesis inside the laboratories. Okay, and then hopefully in the soon we'll have cars which run on water. Right? It is very soon possible. Okay, and then this guy, you know that light, rectilinear propagation of light. We think it always goes in a straight line. But then there were people who asked this question, okay, people ask this question like you, very curious girl. I can see her, future scientist, Madam Curie, I can see her in her. Yeah, very nice. So what happens, how can I bend light? Right? So somebody asked this question, then there's periscopes, etc., which bend light, etc. But the real question of how to bend light was solved by this Narendra Singh Kapani, who found out fiber optics, who invented fiber optics. So with fiber optics, you can make light go any way, any shape you want. So he is called as the man who bent light. Okay, proud that he's an Indian, right? We are all very proud that he's an Indian. Okay, so now we know because of the fiber optics, so many things, communication, everything, so many things are happening in this world. Again, let me jump. Okay, now we'll come to the other part of the story. Okay, see, look at this. This girl initially looked like that. She went to a plastic surgeon and she became like this. This guy looked like this. He again went to a plastic surgeon and he became like this. Right? Do you agree that they have both become beautiful and handsome? You agree? Chitra madam is agreeing. Okay, I understand. So how do we do that? How do you decide how to change an ugly face of mine to become as beautiful as madam's face? Right? I need to think. So there should be something to understand, right? If I want to change the faces. So what happens? So what is so beautiful about our face? Tomorrow go and see in front of your this one mirror. Every day we stand in the front of mirror. Next time you go and watch in the front of the mirror, you will see, okay, what is so beautiful about this? 2 holes here, 1 hole here, 1 white thing coming, some teeth like that. What is so beautiful about this? There is nothing beautiful about it, right? But still we can see what is beauty in that. And that I think is very important, which I want to share for the next 5 minutes. Okay, so now they do these calculations, measure your ratios, proportion, everything and do. So all of you who think you are ugly, you can get this done. Okay, and you will become the ugliest person in the world. That is for sure. Okay, so again, these beautiful things, again, so beautiful in nature. Okay, these are Mandelbrot sets, simple mathematical equations which give you beautiful lecture, and that is how nature works. So nature is showing this beauty. So now everything, if you start looking into details, you have one spiral like this coming. Everything, you know, seeds of a sunflower, you see this, all this, the babies, okay, the octopus, everything, you see the spiral. The spiral is the basis of the world, of existence. This spiral, okay, and that Mona Lisa, why is it considered as the most beautiful painting in the world? Okay, and then this face, and this humans, etc. What I want to tell you is, and also the beautiful buildings which we call in the world, they are all based on this spiral. Okay, they are all based in the spiral, and what is this spiral? And that spiral is the one which decides what is beautiful. Anything you talk about what is beautiful is based on this spiral. So what is this spiral? Even in the galaxies, etc. Okay, here, this is the spiral. This is called as the Fibonacci sequence. It is just a sequence of numbers, 0, 1. Okay, add these two, 0 plus 1, 1. Add this to 1 plus 1 is 2. Add this to 1 plus 2 is 3. Add this to 3 plus 2 is 5. Right? You understand? Previous 2 numbers you add and you get this sequence. And this sequence decides how this nature is formed and what is beautiful. Okay, and that was done by Hemachandra, a Jain Muni of India, 600 years before Fibonacci did it. He did not use it for understanding, seeing the beauty, but he used it for his mridanga beats. You know, because if I beat mridanga, okay, nobody will watch it, right? But if some expert beats, it's so beautiful to hear. Why is this? Because there is a Fibonacci sequence behind it. Look at the instruments. These are all based, the dimensions of the musical instruments is again based on Fibonacci numbers, but it's also called as the golden ratio. 1.62 is the ratio. Okay, 1.62 is the big number which comes out of the Fibonacci sequence, which decides what is beautiful. Because we are also made like that, so we see anything which is made like that as beautiful. That is how the science of beauty is. Now here, this is one, I wanted to talk about tabla. Okay, you can play this, yeah, please.
1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I
feel like dancing. Then he goes on changing the sequence inside that spiral. Now you see here. He's putting more bits into it. Pieces, more pieces, but in the same sequence. Of course, it's there. It takes a long time. So let me jump this, but look at this. These are all available on the YouTube. Search YouTube, you can find this. Only the bit is changing. It's still going in the same spiral. This what decides what is beautiful music. Please understand. Okay, fine. So now, friends, it's still beautiful. Please watch it. Okay, Vinayak is getting very angry with me, so I have to stop here. Okay, so now, friends, so what is it? Is that how do we search for this beauty? It is not about the face. It is not about anything else. So it is of becoming students of science. Okay, then probably you can become a scientist like Professor S M Rao. And this is possible when you marvel nature, respect knowledge, emotionally appreciate the size, which we saw in that video, and the ability to ask questions, pursue and understand. Once you do that, you can understand so many things. All these great scientists I showed, okay, went with this idea of curiosity, imagination and knowledge. They did not go by the degrees BSc, MSc, PhD, right? They went by their curiosity. And that, I think, is very important. Okay, there is other now question is, now are we ready? There are 3 amazing technologies, nanotechnology, biotechnology, and artificial intelligence, which is coming up. So we have to be ready with this knowledge because science will change because of this. The world will change. To give you one example, Cardio and Wood from Cambridge and MIT have done some research, and the title of the paper is Death of Death by the year 2045. By 2045, you may not die. Nobody will die, natural death. If you want to kill each other, it's okay. But if you want natural death, you can conquer it. Isn't it amazing? I will not be alive by 2045, but all of you will be. So you can have your 200th birthday, and when you're 500 years, you can get married. 800 years, then you can get your children. So many things you can do. So this whole concept will change with science. Okay, so friends, this is my last slide. So you see, Plato said, beauty lies in the eyes of the beholder. But Aristotle changed it, and he said, the chief form of beauty are the order and symmetry and the definiteness which the mathematical sciences demonstrate in a special degree. So now, beauty is not in the eyes of the beholder. The beauty is in the definiteness of physics and mathematics. Okay, that's what it is. So now, all the great Indians, and then many more great Indians, and of course, our living legend, okay, Professor Rao, now it is time for you to become one of them. Each of you should plan that next time when I give a talk, your photograph I should use. Okay, your plan. So you can do this, and that's what it is. So now, ultimately, if we want to make Bharat the Vishwa Guru in the modern world, we need to have modern science. Okay, we cannot get stuck in old science. There is a big challenge, big challenges which are coming in the future. We need to get ready for that. So thank you all, friends. Thank you for patiently listening to me.
And one more thing, ಒಂದು ವಿಚಾರ ಏನು ಅಂತಂದರೆ ಇವತ್ತು ಪ್ರೊಫೆಸರ್ ಶಿವಪ್ರಸಾದ್ ಸರ್ JNCASR ಅಲ್ಲಿ ತುಂಬ ವರ್ಷಗಳಿಂದ ಕೆಲಸ ಮಾಡ್ತಾಯಿದ್ರು. ಟುಡೇ ಇಸ್ ದ 30th June, his retirement day, the JNCASR. He is having a... My new life is beginning. Yeah. The birthday of Professor S. Yes. Yeah. He's the director of Government of Karnataka Higher Education Academy. He's right now he is a director. And thank you very much, sir. And we have small gift from the school Chandan because they requested me. And please, sir, please honor him. Yeah, thank you. Yeah. Yeah. Now from Parikrama school they brought some the gift. Yeah. Parikramati. Yeah. On behalf of CNR Education Foundation, and this is a small present to Professor Shivaprasad for giving us such very interesting and brainstorming lecture. Thank you, sir. And this is a small present. Yeah. Now we have a chemistry experiment session now, and you will enjoy. And due to the shortage of time, and we'll do two quick experiments, and after that we'll have lunch, quick lunch. Okay? All are quick. Yeah. Just a moment. And now I request Dr. Jayashree to introduce our next speaker. Thank you.
Good morning, all. First of all, I would like to thank Professor Shivaprasad for a wonderful lecture.
Speak loudly.
Okay. Wonderful lecture. I cannot take, I cannot take myself out of his lecture. Still, I'm the beauty of science. Still inside the beauty of science. So not wasting too much time. Before I introduced our next speakers or next, experimentalist, I would like to take this opportunity to wish a very happy birthday to Professor C.N.R. Rao, and it's all of our privilege that we are here today to celebrate his birthday. So we wish you a very happy birthday, sir. And then now I will introduce you to Dr. Pratap Vishnoi. Pratap Vishnoi is a Ramanujan Faculty Fellow at Jawaharlal Nehru Centre for Advanced Scientific Research, Bangalore, since 2021. He received his PhD in chemistry from the Indian Institute of Technology, Mumbai in 2014. He then carried out postdoctoral studies at the JNCASR and subsequently at the University of California, Santa Barbara, USA. He had recently been recognized as the engineering investigator Emerging Investigator of year 2021-22 by the Royal Society of Chemistry, UK. He has published 45 articles in international journal with more than 800 citation and Edge index of 16. His current research interests are in multifunctional hybrid organic, inorganic materials and halide perovskites, right? And then I would like to call upon Mr. Vinayak Pattar. Vinayak Pattar is an Assistant Coordinator and Education Technology Unit, JNCASR, Bangalore. He obtained his Master's in Physics from Christ University, Bangalore, pursuing PhD in Vishwesarya Technological University. He worked in many research and education institutions. Notable among them are research student at the Indian Institute of Astrophysics, Bangalore, and physics lecturer at KEL College, Bangalore, research fellow at Bangalore University. Vinayak Pattar has pursued research in frontier area such as optoelectronics, nanostructure, thin films, transport properties and materials, glass science, nanoferrities, and nanosensors. And he is the author of over 20 research papers published in international journals. He is involved in many science outreach activities across nation and instructor for college, high school teachers, training programs, and many more. So now I would like to request Dr. Pratap and Vinayak to start their experiment. Thank you so much. Hope you all will enjoy this.
Thank you, Dr. Jayashree, for a very nice introduction. I hope you all are excited that we are opening a laboratory here, but will not scare you because this is all friendly chemicals and we'll do certain experiments. Yeah. Yeah, so you heard about a lot of stuffs, different kinds of beauty-related products, and surgery and aeroplane and various kinds of other science discoveries just from Professor Shivaprasad. And that's very, very inspiring and a lot of knowledge in that. So what we are going to do is we'll talk about chemistry and yeah. So, if you look around, we have many, many stuffs which are visible. For example, you have table, you have chair, you have floor, you have, let's say, a water bottle, and there are many things which are not visible, that, for example, air. So, all of which, in one or the other way, is called chemical matter or material. And they are made of what? Atoms. And there are various kinds of atoms now known. Can you say almost how many types of atoms are known now? 118 or about 20. Okay, a lot of atoms are known. And what chemists do, they combine, statistically through using chemical bonds, these atoms to make different kinds of compounds, elements, and so on, elemental material and so on. And this is in some way similar to, have 26 letters in English, you combine them and make thousands of words. Okay, so if you look in the real world around you, you have the processes happening. There are many materials which I just mentioned, but you see there are processes happening everywhere. It is chemistry. For example, food digestion. You talk about the plants make their food from sunlight and use water and carbon dioxide and so on. You see, you keep fresh iron rods outside, particularly in this season, monsoon season, where there are a lot of humidity and oxygen anyway already there. You will see in a few days, the rust start appearing on the surface of it. That is nothing but the oxidation of iron into iron oxide. So this is a chemical process that happens on its own in nature. We can protect it if we don't supply water and oxygen to that. And look at, this very serious problem though, oxidation of fuel, which we use for energy for various purposes. So this is again a chemical process, one chemical changing to the other one. And we use one very ubiquitous example of chemical, that is NaCl, either table salt or kitchen salt we add in food items. You mix hydrochloric acid and sodium hydroxide, you will get this. So there are few examples, but there are thousands of examples which are called chemical process. But now, let me come back to what I was talking about, chemistry and what is this. So in chemistry is a subject which we study in high school and education higher than that. What we do is the stuff that I mentioned, some of the examples, and there are many millions of stuff in nature we can see, and there are many which are man-made we don't see in nature, but we see in laboratories. So we, out of curiosity, want to know what they are made of. And you just mentioned they are made of atoms. So that is one portion. Now, material is there. How material look like, or chemical look like, or matter look like? What is its phase, whether it's gas, solid, or liquid? What is the shape? What is volume? This one. And then how it changes, one chemical changes to other one. All these studies is actually what is called chemistry. Okay? And broadly, for our convenience, we divide entire world, the materials, into two parts. One that is elemental. Other one is compound. Can you say what is elemental material or element? Anybody? Any example of compound that is around you, you can say it is elemental. Sorry, which one? Sulfur. Loudly, please. Sulfur, no, we don't have around sulfur. In this room. Oxygen. Anything else? Nitrogen, NN. That is element, okay? Oxygen is element. And then a few examples of compounds. Carbon dioxide, and all these stuff, they are compound because so many different types of atoms are in that. Okay, so these are the studies we do in chemistry at basic level, but then there are so many things we do at advanced level. We don't go in that today. But then coming to experiment, what we do, I mean, to learn chemistry that I just discussed, different material, their phases, their color, their shapes, to know that out of curiosity or any other reason, what we should do is mostly the experiment. We should carry out experiment to answer or to quench our curiosity, okay? And in today's this demonstration, we'll look at a few chemical the experiments here, okay? So one of them is this: we carry out the experiment, and we'll ask you to observe what is going on, and then we'll look at the chemistry, what is the process and how it happens, okay? So we'll do the experiment called blue bottle experiment. So what we are doing in this, we are taking a dye molecule. Have you heard about methylene blue? You heard it, right? It's a blue color dye. Dye means any compound, any material which looks colored, we call that as a dye. You know, hair dye, dye is used for coloring clothes, and this, by the way, this dye is also used in certain medicines because this is not toxic dye. Okay, so what we will do is, there are some dyes available commercially which change their color on changing pH. Do you know what is pH? Okay, well, what we do with that? Acid or base we know, okay, and what is the boundary between, what is the pH which segregate acid and base? 7, okay, below 7 acid, above 7 base. So this dye, what it does is, if the pH of the solution is acidic, 7 or below 7, it remains colorless in presence of the other stuffs, okay? Moment you add some base plus oxygen, it changes color. So let's see. We'll see. What is there in this? That's in blue. So what I'm doing is, this one has glucose here. We mix glucose with, there's a lot of water in that, and potassium hydroxide. When we do this, it oxidizes glucose. And where oxidation is happening? At this one, the alcohol group, CH2OH, it goes in acid. And this is basically oxidation process. When you combine another reaction, which is a reduction reaction with the oxidation reaction, you may see some different phenomena that is here. So what we are doing is, the methylene blue, we are now reducing to color. So,
do you know the importance of the dye or indicator? We will use everywhere, even food coloring and all, those are the coloring, the indicators, this chemistry we use. And if anybody gets the chest pain, the heart attack, the angiogram, they will use the dye. That is also one of the indicator. Like that, so many applications are there in the daily applications. Yeah, and in chemistry, these indicators are very powerful tool to know what is the compound. You can know about the compound and what is inside. Okay.
I'll take this. Do you know any other dye that you can name? Any other dye? So this became. So what I did is, I took glucose, then I added methylene blue dye in that, and there was a whiter and KOH already present in that. What happened? It immediately become colorless. Actually, methylene dye is blue dye. Okay. Now, when I shake it, it changes its color. Do you see what color it is now? Blue. Okay. And now you observe what happens in a moment. Oh, color disappeared.
What is happening in that?
What happened?
ಏನಾಗ್ತಾ ಇದೆ ಇದರಲ್ಲಿ? Just I'll show you. Is that magic is going on here? No. Huh? ಏನು ನಡೀತಾ ಇದೆ ಇಲ್ಲಿ? The chemical reaction. Sir said, he said the chemical reaction. Then, any answer? Oxidation? Reduction. The same mechanism, which he already explained.
Yes.
See, what is happening here? Suppose if I'll show in another experiment. Do you have that, the flask, the complete, we can fill that. Okay? See here, the oxidation, how the mechanism is taking place here. Now I am shaking this well enough, then I'll get the blue color, right? Then, how oxygen, how it will combine?
So at the moment, it is here.
Yeah.
Okay.
How is combined? Where is the oxygen here? The air, right? It is correct answer. No, now I'm filling the air now. In air, we have 21% oxygen, right? And that oxygen, when I shake this, like this, then oxygen will mix with the water molecule. Okay? Then you will get that. Then slowly, whatever the oxygen which is inside, it atomizes that water, it will go and sit in the particular, that indicator which he said.
Yes. Okay. So this is what happening. Now let's see what we do. If I pour it like this,
you can do color sharbat, okay?
okay, and now
the juice.
It became blue, right? Now let me do. Let me do it again. Let the color disappear. It disappeared. Let me do it not on height, but like this.
Because there is no oxygen, it's going inside.
You don't see.
So very slowly, if you pour it.
Changing. So this is you're changing oxygen content back and forth. When you are dissolving oxygen, this is what happens. And when you keep it for some time, oxygen is utilized, what is dissolved, it goes there. And now, there is a question here. It's a quick quiz for you. By looking at this formula, can you say why this is colorless? Hydrogen is on nitrogen. That's the difference, right? So what? Loudly. Exactly. It lost its conjugation. So see, the two benzene rings which are separated and by a couple of single bonds. So these three bonds cannot, commute between these two rings. Whereas they can travel here, so conjugated. So the conjugation is important. Once conjugation is there, they become colored, start to absorb in visible light. Okay, okay, now we'll do, what we played is about two colors. I mean, one is colorless, of course, but the other one is blue. Let's see whether we can do experiment with dye which can show multiple colors, more than two. Okay, let's see. So again, this is, I'll skip. Again, we are taking another dye which is called indigo carmine, which is a solid compound commercially available like this. You can buy in market. And when it is solid, it's blue in color. It's a blue color solid. But moment you put in the glucose solution, which I shown in earlier slide, here, glucose dissolved in water plus potassium hydroxide. If you make this solution, and in that solution you add indigo carmine, you will get 3 different colors. And let's see what those colors are.
Now I perform the magic now. Here, I have a solution here. The chemicals which you put here, the same glucose and KOH. Okay, then we use the indicator, different indicator here.
That I explained. This is the one.
Yeah.
So you had this solution, you put that blue dye in that, indigo carmine, and you will see what is happening in this beaker. Yeah. This beaker is equivalent to this bottle here. So
yeah. Now
let's check that what happens.
If I shake it, can you see the color? The green color, right? What? Blue? Yeah.
Yeah, green. Yeah, I see it's green.
Somebody said green. Now you can see now. It's going to change now.
I don't know whether it will change.
No.
Oh, this is changing.
The color is changing, right?
What's the color now?
It's red.
Red.
If I leave it for some time,
I think it will change again. I'm not sure though.
see?
What's the color now? Yellow. So, can you guess? I drawn the picture, the dynamics here. Can you say what is happening? Okay, when we add it, the moment we add it and second it well, oxygen got dissolved in and you got this dye. That was the green color. And you keep it like this, it will remain forever like this color. Okay, now I am starting the process again. This is what I want to do. So shake it well. This is what it is. Okay, now difference is, in this particular dye, there is a difference here. These two carbons are so important. Okay, so when these are both oxidized in ketonic form is green. Now what happened is, it slightly got reduced because some oxygen is consumed, is decreasing, so it's partly reduced. That is what it is. So one carbon is now reduced. You see, is alcohol. Other one is still ketone. Okay, now its further process is going on. What happens is the complete reduction. You see both this carbon is hydroxyl now and this also becoming hydroxyl. So you see it become yellow color. Okay, now let's see, I've drawn it as a reversible. You see it can go back and forth. Let me, don't shake it too much, but let me shake it very little. This much only. You see what happened? It just has come back here only. And then it's going back. It's doing that much only. But if I do it so much, you didn't see it. It actually passed through this red dye, but it was very quick, momentary. You cannot see that. It came here, now it's going back to the yellow dye. Okay, so this is very, very interesting experiment where one light is showing 3 colors. Okay, now, can you compare these 3 colors with any real phenomenon when you travel? Traffic light, exactly. So these are the 3 colors you can see in this dye. Okay? So now it's a yellow forever, means You have to be at signal if you are in traffic jam. Okay, so now Professor Shivaprasad told that about energy, right? There's a lot going about energy. So what is one of the energy sources? You know, the fossil fuel, which is creating a lot of pollution, and also it will get over in some years, we don't know. So the alternative is what? One of the alternative is to produce hydrogen out of water. Water is, the formula is what? H2O. It means it has hydrogen, it has oxygen also. If by some way we can break water easily into hydrogen and oxygen, and hydrogen we can use as a fuel. But the problem with this reaction is this. This reaction is non-spontaneous. What is a non-spontaneous reaction? It does not take place on its own, right? It needs some force. The reason is that if I'm sure some of you may be aware of activation energy. It has high activation energy, so you have to provide that energy to this reaction to happen. Okay, and here what we are going to demonstrate is we are giving electrical energy, and we are making the water hydrolysis cell, and we'll show you the hydrogen coming out. So here is the cell.
You can also do it at your home.
Yeah, you can do that.
Right? Okay. This is a pencil. And we have the graphite right inside, right? What it does, it does black. We just tried here. You can see, and you can see the bubble. You see now? The same thing.
So what you see here is this. So there are two electrodes, anode and cathode. Is that right? This is setup what I'm showing here in the picture. It's a pictorial, but this is what is the video of that one. You see bubbles coming out at anode and cathode. Can you say what are these bubbles are respectively? Like in anode, what are these bubbles of? And what is there on cathode? Great. So this hydrogen, if we can break water with a less energy input, this hydrogen can be a great future fuel. Can be prepared at large scale. A lot of research going on in this area. Now, coming to one question, you see the amount of bubble which are coming on anode and cathode, they are not nearly equal in number. Like, which electrode has more bubbles? Cathode. Why so? Say it again. The difference in molar ratio which is produced. Exactly. Okay. So what happens if you are producing hydrogen twice compared to oxygen? How much difference in volume you expect? For the number of moles are the twice the number of oxygen in case of hydrogen, right? The volume should be twice, right? Great. Okay, let's talk about few more stuffs. Acid and base. And this is, again, you find very frequently around you in food items and in laboratories, and they're so useful. We used one or two acids, base we used in the dye experiment. So acid base, let me quickly tell about the acid and base. The acid is something that can give proton when you put in water. Is that right? And when this happens, pH will be somewhere below 7, depending on how much you are reading. If you have a base, that gives what in water? OH minus, hydroxyl ion, and pH will increase above 7. Right? If you mix acid and base of equal strength, you will get what? Salt. Okay? So, and this is a brief picture we are showing. You can dissolve this thing in water and see the solution become acidic, basic, or neutral if you used the acid and bases of equal strength. If there is a difference in strength, what will happen to the pH? For example, you have a strong acid you used for making salt with a weak base, what will be the pH of the salt if you dissolve in water? Okay, so it's decided by the stronger component, right? Great. And if you look at around, again, food item or in nature, you'll see at several places acid you find in very frequently. So let's take examples of few of the items that we see in daily life. So hydrochloric acid, where we have in our body? Where? What it does there? Okay, is there anything else it does? Kills bacteria. Okay, and when it becomes imbalanced, what it does? Okay, so these are certain examples. You want to show that? Okay, so and we'll not go through these, but what we essentially, because there's so much acid around us in food items and everywhere, how we can test? Again, how can we quickly do experiment and say is acid or base? So let's do one test, that is, this is litmus paper test. You can do litmus paper available. You can dip in acid, base or salt. You can see depending on color change. But this is very, very famous acid test called phenolphthalein test. Have you heard about it? Yes. Okay. So, and we want to show this. What is it? Something is written on this board, but we don't see. That's invisible. Where is phenolphthalein? What is that you write there? Text. No, text. See? You write no? So now you see this is colorless and you don't see anything here, right? So let's write the slogan of our program. What's that? See. What you write here? Ask. What you write here? Think. Good. So this is how we learn science.
First of all, what is the color of this?
Okay, they got it right? Yeah. Okay, so why we got pink color? This one. Phenolphthalein. And again, I mentioned in earlier dyes, many dyes are so useful, they change their color depending on pH. Phenolphthalein becomes pink when it is in basic medium, above pH 7. Why it becomes? What the reason? What's the reason? You see there's no conjugation here. There are single bond at the center, but you see these double bonds are in conjugation. So the larger conjugation, electrons can travel across this molecule. You see this is showing a color. Okay, so with this, thank you.
So I would like to thank Professor Vishnoi and Vinayak Pattar for a wonderful presentation and wonderful experimental. I hope all of you enjoyed, but still I feel your faces are a bit dull. Maybe you are hungry for food. So on behalf of Professor Rao, CNR Rao, Education Foundation, I would like to give them a small token of love. Thank you once again, Professor Pratap Vishnoi and Vinayak Pattar. So maybe we have the time for lunch now. Yes. And after lunch, we have to assemble here. What time?
Yeah. 1:30 exactly.
Exactly 1:30. If you are interested to know something very interesting today about the caves, so be here at 1:30. I'm going to give you a very exciting lecture on cave. You must have seen the caves. So we'll tell you something scientific about the caves today, okay? So if you're excited, I expect you here at sharp 1:30. Thank you. Looking forward to see you.
See, the cave talk is, it's a very beautiful talk, and it's the first time you're going to hear that. Okay? Don't miss it. You have to be here at 1:30 sharp. Don't make noise and go and have the lunch. Thank you very much. Yeah, bye. And now I request Dr. Pratap to introduce Dr. Jayashree Senmal Bhatt. Sir, please.
Yeah. Good afternoon, and thank you, Ms. Vinay, for the invitation again to introduce Dr. Jayashree Senmal Bhatt. So, a silent please. Yeah, good, thank you. So Dr. Jayashree Senmal Bhatt is a DST scientist at the Jawaharlal Nehru Centre for Advanced Scientific Research, Bengaluru. She works in a department called Geodynamics Unit at this institute. She obtained her doctoral degree in 2003 from Kumaon University, Nainital, and did postdoctoral research at Freie University, Berlin, and Simon Fraser University, Canada. She was always fascinated by nature and spent a reasonable amount of time outdoors, venturing into Himalaya trails. Eventually, her passion for geology took her from the Himalaya mountains to the Andaman island to explore the mysterious hidden in rocks and sediments. So our research focuses on identifying the significant linkages between climate, surface processes, and tectonics using geological proxies. So may I kindly request Dr. Jayashree to please deliver a lecture on what caves tell us about the climate.
This is next slide, this one. Pointer. Okay. Thank you. So welcome back, all of you. Good afternoon, everybody. Good afternoon, everybody. Oh, you just had lunch, but still there is no energy. Why? I'm sick, but still I have more energy than you. Good afternoon. Yes, that's what the energy is. So today I will be telling you, not teaching you, I'll be telling you some excited points about the caves. And before that, I would like to thank Mrs. Indumati Rao for giving me this opportunity to talk about my science in front of you. So then let us begin with my talk. So how many of you have visited a cave? What do you know about the cave? Oh, many people. What kind of cave have you visited? May I know? What kind of cave have you visited? Okay, never mind. So let us start with, so today I will be talking about what cave tell us about the climate. See, you have been seeing caves and get excited to see the beautiful natural marvels, you know, and exciting structures inside the cave. But how geologically they are important, how scientifically they are important, this is what I'm going to tell you today in my small lecture. So this is the figure. As he says, I can't move anywhere. So this is a figure here. You know, when the humans started occupying the earth, have you any idea, any of you have any idea? It was 200,000 years before present when we humans started exploiting our earth. So the story begins from here. We say today the climate is changing, we are making a hue and cry that climate is changing about global warming and all. But do you think these kind of climatic changes had happened in the past also? Yes, during the geological time, the climate has been changing due to many natural regions, like solar cycle, you know. So all these things, all these natural factors are responsible for changing the climate. And because now what we are doing, the natural climatic cycles have a longer scale. But what we are doing, pumping a lot of carbon dioxide to the environment and changing it very frequently. If this year we see the weather, what is the climate? Today, if I have a cold weather today, tomorrow if I have a hot weather, will I say the climate is changing from today and tomorrow? Not, right? Climate is a long-term process. It cannot be represented in terms of days. So when I say that the weather is changing, so weather is changing from morning to evening, from evening to next day, and from day to weeks, from month. And when it becomes in the yearly scale, that it becomes the climate. So this is how we say the climate is changing. So we are pumping a lot of carbon dioxide to our environment, so the climate is changing very rapidly. We see a lot of change around us, frequent changes around us, erratical rainfall, too much heat sometime, and too much waterfall, too much of springs sometime. So this is what is causing the changes. So these changes have started actually long back. You won't even know what we humans were doing in 200,000 years before present. When we started burning, when the spark came, right? And we started burning the fuel. We started cooking our food. It was sometime here. But at that time, the climate was not warm enough. The climate was very cold. But still, slowly, there were a lot of natural sources that the climate started getting heat. This is a Toba S. And then you can see this is a cold period. So from 200,000 years to 200 years, if you see, this is how the climate has been changing in the past. So see, here was it was an ice age, then you have the climate slowly became, modified, and then again it was an ice age, and then again. But if you see last 10,000 years, it was known as last glacial maxima, which existed for about 2,000 years. It was in 18,000 years before present. None of us were there, but our ancestors were there who has experienced that. Right. So from there, if you see after that, approximately around 10,000 years, the climate has not been changing much on the global scale. And here we comes. This is how we started our evolution. If you see monsoon, climate, and evolution, migration of human, everything is very much related to each other. Today, if we talk about GDP, that also depends on the monsoon, right? That also depends on the climate. So climate is a very important, very vital part of all human beings. And this climate has been responsible for collapse of many civilizations which were existing before, but there are no more. Can you name any of such civilization in the past? In India, Harappan civilization, which existed about 4,200 years before present completely. Okay? And then all of you must be knowing about this cartoon. Do you know about this cartoon? Have you seen Ice Age movie? Is it Ice Age, right? Continental drifting, Ice Age movie. So how do we know that there was an ice sheet during that time when there was no human? Today, how do you know that climate is changing, weather is changing? Because we have the instruments. So the instrumental data tell us that how your peaks increasing, how the heat is increasing. But that time, they have no such instrument. These guys has no instrument. They were just walking around. Then how do we know? If I have to reconstruct the climate in the past, how we do it? I need some proxy. I need some proxy to reconstruct the climate. Where comes the role of a geologist? So we have different kind of proxies in our geological world. Like if we want to go back into time, we have tree rings. Everybody appreciates tree. But if you cut the tree, you can see the small rings around. So each ring represents 1 year. So 1 year, how much precipitation had happened in 1 year and how the temperature has changed in each year get captured in these small laminae of tree rings. Same as you have biological proxies. These are the proxy called forams, and these are the proxy. Again, for climate, they are mostly in the sea, these kind of biological proxies. And then you have ice core. You must have heard about the ice core, how people go into Antarctica and Arctic Sea and even the Greenland and take the huge pile of ice which get accumulated every year. And based on that data, they interpret the climate, how the climate has been changing in the past. And the same as we have these many continental and marine archives to understand. So today I will be mostly talking about the cave deposit. Let's see how cave talks about the climate. So this is what is the topic of my talk today, is tracing the footprints of long-term climate locked in the cave deposit. So Dr. Pratap told you, and in the morning session also, Sir talked about the chemistry, isn't it? So now, what is this? It's a water drop. So do you know the chemistry of water drop? H2O. So this chemistry can be very, very important, the chemistry of water. So now we see the beauty of a water droplet. A water droplet which comes from the meteoric water. How it gives us the information about climate and temperature and precipitation. So this is how the caves looks like. The caves, which is a geological wonder. So caves are basically the natural underground voids caused by diverse geological processes in various rocks in many ecosystems. So what you see here is a strata, which is made up of limestone, basically CaCO3, calcium carbonate rocks. So when the CaCO3 interact with H2O, then the story starts here. So, and the scientific study of caves is known as speleology, which is nothing an amalgamation of different subjects, amalgamation of chemistry, amalgamation of physics, amalgamation of chemistry, and archaeology. When these subjects are mixed together, then becomes a speleology. So not only us, even the primordial humans were also attracted towards the cave. If you go back to the history, the humans have been very much attracted towards these, these natural structures because they want to take a shelter. So for shelter, these were the best place what they could get because they didn't have any houses like we have today. So they wanted to protect themselves from the animals. So what they used to do, they used to find out some shelter which can save them from animals, from the natural calamities, rain, excessive rains, and other heats and all. So if you see the prolific evidence of human, so this is 130,000 years old female Neanderthal skull, which has been Tabun Cave, Israel. This has been discovered from. So since then, the human has been living in the caves. And then you have another Neanderthal one from Neander Valley, Germany. This is the oldest known fossils so far. And these are the another skeletal remains. And apart of it, we have a lot of cave paintings also, which also gives us a clue that humans have been living in the caves for several years. So a part of these things we also have in India, there's Bhimbetka rock shelter. There also we have a proof that around 13,000 to 12,700 BC, the people they were cave dwellers who came and occupied this particular land. So as if I go, so there are different kind of cave, just not one. So there are several caves. There are solution caves, lava caves, sea caves, glacial or ice cave, talus cave, regolithic cave, and vein caves. but I do not have much time to focus on all these things or even give you an introduction. So let us focus on solution and crust cave. What exactly? See the beautiful cave. What comes to your mind? See? What is written here? See. Ask. First think. What comes to your mind? You know, this is a roll of a water droplet, which I showed you initially, H2O. Reaction with CaCO3. So this is how beautifully these structures are carved. Okay, so now let us ask how these structures are formed. So the story again goes back to millions of years. How these limestone forms. First the limestone will form, then you will form these kind of structures, right? So again it goes back to around 200,000 years when there was 300 million years rather. So when the earth was, most of the part of earth was underwater. We have a very small continental. That time all the sea animals like forams, bivalves, and phytoplanktons, and all these animals were, in absence of human, were very happily surviving in the ocean, deep oceans. And slowly when they die, the disintegration and their deposition became the calcium carbonate, because they have their shells are made up of calcium carbonate. So they got, this calcium carbonate got deposited beneath the ocean. And this is how formed the limestone. And then this was the first stage. Your limestone is formed, your calcium carbonate rock is formed, and then comes the role of water droplet. What water does? So the earth or soil, usually you know that the calcium carbonate is insoluble in water, in pure water. If you try to dissolve it in pure water, it will not dissolve. It will take a long time. But if you make it little bit acidic, as Dr. Pratap told you, the difference, you know, the difference between the acid and base now. So how this particular water becomes acidic? You have CO2 in environment. When the raindrops falls, when the meteoric water falls, it absorbs CO2 from your atmosphere, and then it takes CO2 from the atmosphere, carbon dioxide gas produces by biological activities and others, and then it seeps through the soil. And from soil, it takes additional fulvic and fulvic acids. So all these mixture of CO2 and fulvic acid makes a very light acidic nature of the water, that particular drop of water, which seeps through these rocks. So now these rocks can be easily diluted in the water, because that water has already become slightly acidic now. Not too much acidic, slightly acidic. Okay, so then this water penetrates down, and then what happened? So the water seeps into the ground, it picks up a great deal of the carbon dioxide, making a weak carbonic acid. Okay, as soon as carbonic acid encounters limestone, it begins to dissolve the wall of cracks and other openings through which it flows. You can see the water is coming from here, and then now it has started dissolving the walls. And when it starts dissolving the walls, then you will start creating the hollow structures inside, and different kind of structures which I showed you earlier. This is exactly the chemical process. What happens? The raindrop fall, the meteoric water, your rainwater picks up CO2 from atmosphere, picks up some weak acids from here, becomes acidic, penetrates through the calcium carbonate rocks, and then these are the unsaturated zone, and the water droplets also become saturated in calcium carbonate because it dissolves the calcium carbonate, you know. And then this is a chemical process, and here you can see the cavities are made due to the dissolution. So caves are basically, where inside one human can stand. We can enter the big, huge cavities when we can enter. So we have different kind of structures inside the cave. So the structure which grows from floor towards the top, towards the rooftop, are called stalagmite, which grows from top to bottom called stalactite. When these two structures grow together, when they meet and grow together, they are called column. Like that, you have different kind of structures. So we have several caves in India, not only in Himalayan region, even in southern India, you have lot of cave. Wherever you will have limestone and the water reaction, you will have these kind of caves. These are some examples of the caves and the kind of work we do. So this is how a cave passage looks like from a distance. This is a different kind of cave, which is an open cave. So to understand the science behind cave, it is very important to understand the present environment. To understand it, what we do, we collect different kind of samples. We collect rainwater. If I'm working in the Himalaya, then I collect the snow samples to understand what kind of oxygen isotope we have in there. Okay, so as I said, oxygen isotope. Okay, so I have here two balls. Can you see difference between these two balls? Can you see the difference between these two balls? No. If I say this is weight, this is light, this is heavy, is there any difference? Weight. So these are called isotope. This is oxygen 16, which is lighter, oxygen 18, which is heavier, okay? They look exactly same, but the only difference between the proton and neutron. Proton will remain same and the neutron will change. So 16 and 18 you have in your atmosphere. Breathe in. When you deep breathe in, what do you take? Oxygen 16, because it is easy to take oxygen 16. Oxygen 18 is heavy, so our body will not take until I have deficiency of oxygen 16 in my environment, okay? So this is exactly how it works in the nature. What happens when you evaporate the sea? So in sea, you have both the molecules. You have delta 18O, delta 16O. So what happens when the moisture goes away, when the evaporation starts, what kind of molecule will fly first? What kind of molecule will evaporate first? Lighter molecules means delta 16O, right? 18O, since it is heavy, it will take lot of time. So what happens in any kind of monsoon period, when the moisture starts going up, it takes lot and lot of delta 16O inside, and it goes to the in the air in the form of cloud and moves away. If you can imagine India, so what happens? The maximum moisture is taken from Arabian Sea. So Arabian Sea, delta 16O and 18O will be carried away from evaporation process. So 16O, since it's lighter, so you will have lot of 16O molecules in the air. Okay, H2O. The 16O molecules you will have lot in the air, and it will drag towards the north. And what happens there? What makes the boundary? What makes the barrier not to resist this moisture, so that the moisture doesn't go beyond towards Tibet? What we have? Barrier. Mountains. We have Himalayan mountains, right? So Himalayan mountains makes a barrier. So what will happen? So all the ice sheets you will see there will have lot and lot of molecules of 16O, right? So ice will have lot of 16O when you have lot of evaporation. And what will happen to the sea? What will happen to the sea? the C will deplete in 16O and will increase in delta 18O. So the heavier molecules of oxygen will remain in the C and the lighter will move away, right? This is exactly what happens and how the climatic reconstruction is done. When you use a proxy, the C proxy, this is exactly what happens. We see what was a percentage, okay? We calculate the ratio of delta 18O and delta 16O to understand that what kind of ratio of isotopic ratio of oxygen we have in our sample. Based on that, we can calculate the temperature and we can calculate the past precipitation, how much rain we have in that particular year. So coming into the cave now, this is a cave structure. These are called stalactite, as I showed you earlier. So what are these stalactite? When the water starts dipping from top to bottom and its surface of the soda straw deposits calcite stalactites, okay, it starts to begin form. So you can see the water droplet. You can imagine the soil. You can imagine the limestone strata. The water was coming through this and then dripping. Now this water, what it has? It has both the oxygen, right? It has 16O and 18O. Now 16O and 18O. What will happen to these two, we will see. Now the water will drop. Can you please play the video here? So I will show you what happens here exactly. See, the water is dropping. Okay? This water drops here. If you play the video once, then you can see. See here also, you see the water drop here? So water drop is falling on the stalagmite. This is stalagmite, which grows from floor towards the, from surface to surface. And this is what is happening here. And now you have both oxygen, both isotope of oxygen got captured in. They cannot escape. It's just like a soda pop. You know, when you open tip, so what happens? Your oxygen goes out and other calcium carbonate get deposited. It's the same process happens here. And this is how you make the annual laminations. So the water was saturated in calcium carbonate. The calcium carbonate you can see get deposit here and rest gets evaporate. Then you have oxygen 18 and oxygen 16 here. So this is how exactly it works. So calcium carbonate, basically they are aragonite and calcite, okay? And when it comes from surface to the stalactite, then a part of oxygen, do you know what all it gets deposited with? It brings uranium with it, okay? And get another minerals also. So based on the percentage of different kind of mineral, based on the different kind of mineral, their percentage, their ratio, we calculate the past. We reconstruct how the climate was during that time. And this is how, when you cut the stalagmite, this is how it will look. You can see the annual laminations here. So each lamina represents 1 year of rainfall and many a times the temperature, how the temperature has changed over the year. So we have the complete strata, the complete picture of when the speleothems start growing inside the cave till the end. And then you can see the lamination. This is how. I have taken a small laminae here, and this is how the aragonite crystal looks like inside the thin laminae. And I was talking to you about uranium. This uranium gets clogged in the calcite crystal. And what we do in this calcite lattice, this particular uranium, which is coming from the land, it gets converted into thorium. This is uranium-234, and thorium 237, it gets converted. So due to their thorium ratio, we have a half-life. We can calculate the half-life and understand that how old this particular stalagmite is. Okay, so this is exactly what we do scientifically, and this is an age data, what we have gained after using uranium thorium ages. That's why I said uranium is important, because it gets deposited, it gets converted into thorium. So we can calculate the half-life of thorium. Based on that, we can date this particular sample, and we can know the climatic fluctuation, how the climate has been changing in the past. Likewise, I told you the magnesium, calcium, and strontium calcium ratio also tells us. See how beautifully this data is matching together. So whenever you have the higher rainfall, the magnesium calcium ratio is very low. Why magnesium is low? Because the water is precipitating very fast and seeping through a very fast rate. It is not getting much time to interact with the calcium carbonate rock. Okay? So the percentage of magnesium and strontium will be very low. But in other way, if you have drought conditions, if you have very less water coming inside the cave, what happened? That the interaction time between the water drop and the rock is more. So you have more time, water has more time to interact with the rocks, and that it dissolves the magnesium and strontium, it gets deposited. So whenever you have drought period, the magnesium calcium ratio will be very high, strontium ratio will be very high, but we will have the depleted value of delta 18O. So this is another example. This is a sample from Kashmir. So we have the complete climatic record of last 16,500 years, how the climate has been changing. If you remember the first slide where they were dancing, the animals were dancing. So this is a record of that. This was a cold period. And I just put this slide because you must have heard about this Meghalaya age, right? Yeah. Meghalayan age, right? You have not heard, okay? So we are living in the Holocene time today, and the Holocene time also stratigraphically. And even this Holocene time, okay, if you have not heard about Meghalayan age, have you heard about anthropogenic? Anthropogenic? Okay. Anthropogenic is like people call this era is an anthropogenic era. Why? Because we are dumping a lot of things, we are spoiling our nature, and that's how the climate is changing, the global warming, it is all due to the anthropogenic effect. So this particular era, some scientists also call it as anthropogenic era. But based on this particular sample, this comes from Meghalayan cave, northeast India. So they have found out a very peculiar period, which is 4,200 years before present, when the Indian summer monsoon were declined. Okay, it were declined, and we had a prolonged drought period. And this was a reason where so many civilizations got collapsed, including Indus Valley civilization. Such a modest, modern civilization also got collapsed due to this particular 4.2 event, dry event. So this is why this particular event is very important, and after that it is known as Meghalaya event. So I just, at the last, I just want to tell you, whenever you are visiting the cave, please experience the thrill without destroying anything, protect the harmony and beauty of caves, leave nothing behind except your memories, and avoid making unnecessarily impact to the cave, because caves are the home of fragile ecosystem. Thank you so much.
It was really a nice presentation. We liked it very much. Even the students, they were very eager to know about it. I saw their faces. And one more thing. We came to the last end of the part of this the lecture series. Then, on behalf of CNR Rao Education Foundation, this is a small presentation to Dr. Jayashree for giving us such wonderful lecture. And ನೀವು ಹೋಗಿ. Okay. Okay. Now, last part of the program, that is vote of thanks. Okay. On behalf of CNR Hall of Science and Education Technology Unit, we express our grateful thanks to Professor S M Shivaprasad, Dr. Pratap Vishnoi, and Dr. Jayashree Senwal Bhatt for giving us a wonderful and interesting lecture and also chemistry demonstration by Dr. Pratap. We thank the President of JNCASR, Professor G.U. Kulkarni, for extending his support and facilities for this particular program. Our thanks to the Mr. Jaychandra for welcoming the gathering and Professor T. Govindraju for convening the program. We thank Mr. Dwarkanath for coordinating with the schools and colleges in Bangalore to participate in today's lecture event. We thank the students and teachers and online participants. Okay, we thank all the resource persons, the supporting staff, and the administration for the providing the infrastructure, facilities, and administrative support for this program. Thank you very much. One announcement last, you disconnect made. Okay, we'll have a very short tea break, 5 minutes. Okay, then 2 minutes. You are laughing. Then 1